Utilities featuring Lafayette, Louisiana. We'll go ahead and get started. I'm Galen Lawrence. I'm with the Cadmus Group, and I'll be supporting today's virtual workshop. And I'll go ahead and pass it off to Alyssa Hall.
Thank you so much, Galen. Welcome, everybody. Thank you so much for joining us today. Like Galen mentioned, my name is Alyssa. I work for the Cadmus Group as a consultant for the United States Environmental Protection Agency, who is putting on this morning or this afternoon's workshop, excuse me. Lots of time zones here today. So I just wanted to introduce myself. So I have a background in climate change resilience, and one of the things that I do for the EPA is help to conduct these CREATE exercises like the one that we're going to feature that we did with Lafayette Parish, Louisiana, earlier this year. And yeah, we do these exercises for them, and we help them put these workshops on. And our primary client is Steve Fries, who is with the Creating Resilient Water Utilities team. And I'll go ahead and have him introduce himself, and then we'll get going with our agenda today.
Thanks, Alyssa, and thank you everyone for your time this afternoon. I'm looking forward to the presentations, and I hope you are as well. As Alyssa mentioned, we're part of the Office of Water and Headquarters EPA, and this is an extension of what we've been providing in terms of technical assistance for the water sector, ensuring that climate change and the threats and the impacts from the changing climate are included in a security portfolio by the water utilities. And we're doing our best to reach out and provide not only direct technical assistance with individual communities and utilities, but then have events like this where they have an opportunity to share their experience with us, as well as talk about what they did before and after, and what they plan to do after this exercise. And you're going to hear a lot about other parts of this region of the country in terms of the challenges that are there, and some of the solutions that might be in that space. And we're hopeful that through this experience, you'll learn a little bit about your peers, what your peers are up to, and what we have to offer, and then we'll continue this conversation. And I'd also like to thank the Southwest AWWA chapter for helping us bring together this group and with the outreach for this event. It's very much appreciated, and it's the types of relationships we want with our partners in the sector to continue to make sure that we can reach as many utilities as possible by what we invest into this work. So thank you.
Yes, absolutely. Thank you. All right, so we have a few objectives today and a very packed agenda, so I'm very excited to get started. First, we're going to take a look and learn a bit more about the climate trends that are projected for Arkansas, Oklahoma, and Louisiana. We will also learn a bit about some of the extreme weather impacts to utilities in that same region, and hear from some of the water utilities that are providing services in those states. And we're going to hear from Lafayette Utility System from Lafayette Parish about their CREATE exercise and dig into the details on that. And then finally, we're going to discover some of the capabilities of CREATE and the functionality that you all could tap into as this free resource that EPA provides. So those are the things that we hope to cover today, and we'll do so in this agenda that will be coming to your screen. Great. So again, we're having a quick introduction. Rob Perillo from KATC, who I've heard needs no introduction, so I'm sure you all know him. He's going to do a quick climate impacts overview for Louisiana, Arkansas, and Oklahoma. And then after that, we will have opportunity for Q&A. So questions for Rob would be available at that time. And then we will do 3 presentations from Mr. Ron Spooner, Miss Linda Smith, and Miss Joan Gausvik of New Orleans, Arkansas, and Tulsa, Oklahoma. And then we'll do a Q&A for those presentations, and they'll talk about the historical extreme weather that you all have experienced in your region. After that, we'll take a quick break. And then after our break, we will have a CREATE introduction that Galen is going to give that will tee up the presentation that Trevor will give from Lafayette Utilities System to talk about the climate, the CREATE exercise that we conducted with them earlier this year, as I mentioned, and talk about some of those results that we found. And then finally, I will do a create demo and a Q&A, and we will get into kind of how the tool functions and how you can use it and some of the customization capabilities that you could implement when you do this, do that work. So I'm going to go ahead and stop talking now and hand it over to the excellent Rob Perillo. I'll just give a quick introduction, even though I've heard he needs no introduction. So Rob has about 33 years of experience in forecasting Acadiana's weather and has traced hundreds of tropical storms and hurricanes during his career, including major Louisiana storms such as Andrew, Lily, Katrina, Rita, Gustav, and Ike. Rob is the most honored meteorologist in the state and recipient of more than 25 Associated Press awards, including for Best Weathercast, Breaking Weather, and Best Meteorologist categories in Louisiana and Mississippi. Most recently, Rob was named the 2020 Broadcaster of the Year by the National Tropical Weather Conference and was the only broadcast television meteorologist nominated for the prestigious National Weather Person of the Year for 2021. So Rob, I will go ahead and hand it over to you.
Well, thank you so much for the intro. I feel like my presentation is done. You just made me feel better. Thank you so much for having me. I have a little bit of a show here, weather show, that is geared toward not so much climate change itself, but what we are observing. And this is kind of a softer way of presenting climate change data. And what I've done, I've been doing weather for nearly 40 years now. I did have a career before television, but what are we observing in the last 30 years and how it's been more even magnified just in the last 5 years on things that impact Louisiana, the Gulf Coast, all the way up through Oklahoma and Arkansas as well. So, of course, my show is going to be a little bit more Louisiana and Lafayette specific, but I'm going to give you a couple of case studies and then talk about the statistics that are involved. So, in addition to that fine introduction, just for a little levity, I'm just not another pretty face on TV. Now, mind you, I've been told I had a face for radio and a voice for print. So here I am 30 years into the business. But before I got into broadcast meteorology, I do have a degree in meteorology and I have extensive coursework in all the stuff that you see there. And including the first jobs, I worked as a research assistant and then ran a research project. I worked for a nuclear power plant, actually several. Did emergency planning and worked on dispersion models in case radiation was released, that type of work. I did teach weather and ocean, physical oceanography, and then went into the private sector when I moved to Houston back in the mid-'80s and worked as a marine and industrial meteorologist, which concentrated on the petrochemical industry, worldwide platforms, that sort of thing, shipping industries. And then for the last 2 years before I got into TV, I was an aviation forecaster on a worldwide basis, and one of our big clients was NASA. So that was a cool job. But this gives me at least some bona fides to talk about climate and what we have been observing over the last several years and what can we infer from that. So let's just take the last 5 years, for example. The highlight, I don't know if you can see my cursor here, the highlight for Louisiana, Texas, 2 big floods, and then a Texas-Louisiana flood. All of those were 1,000-year floods that year, $46 billion worth of damage. The Louisiana flood was rated at 25 to a $30 billion storm. 2017 saw Hurricane Harvey as being the low light. Irma was also a major influencer in Hurricane Maria impacting Puerto Rico. And then, of course, your wildfires, severe weather events. But we went from 46 billion in 2016 to 306 billion in 2017. 2018 back down to about 91 billion. The worst event was Hurricane Michael on the Florida Gulf Coast. That was a Cat 5. Florence on the East Coast. And of course, you're always going to see the wildfire icon in the West from here on out. That is a new trend and a continuing trend. 2019 was the 5th consecutive year in which 10 or more billion-dollar weather and climate disaster events impacted the United States. That also included, let's see if I can see, let me just minimize this on my screen if I can. I don't think I can because this is just kind of blocking out my screen. But once again, hurricanes, we had a Hurricane Sally actually in 2019. It wasn't that bad, but we did have a hurricane here, minimal damage, St. Mary Parish. Then 2020 was a biggie. You can see all the climate disasters and all the hurricanes populating the Gulf Coast and along the East Coast. Wildfires, record wildfire season in the West and Pacific Northwest. Record number of storms, 12 making landfall, and we'll get into the details on the landfalls here locally. And 2021, as recent as this is as of September, showing the number of storms. Of course, the main impact maker was Hurricane Ida here in Southeast Louisiana as well. So, and what we're also noticing is that temperatures continue to increase. Cat form for the second year in a row, Cat 4 or 5 storm. Ida may go down as a 5. We're not sure yet. We'll wait on the final assessment this winter. But we have some record Gulf Coast rainfall. 75 inches to date in Lafayette. Our normal is 60. 100 inches plus Waveland, Mississippi, and around southwestern Mississippi. And what we're just culling from trends. We're not looking at models. We're just looking at trends. These billion-dollar events are more frequent, and they're costing us more and more. And this is certainly, statistically speaking, you can ferret out that climate's a part of it. So let's just look at 2016. It was not a tropical depression. It was a weak disturbance. We had super high moisture levels, and we had 20 to 30 inches of rain from Baton Rouge to Lafayette. And in 2016, including the northern portion of the state that had a major flood event, 56 of 64 parishes experienced severe flooding. And we had at least 13 fatalities with just the August event. So hopefully this movie plays. This is just the August event, just kind of showing you on satellite imagery what it kind of looked like. It was just repetitive thunderstorms. And this is part of the new paradigm that we're seeing on these slower moving, more moisture laden tropical weather systems. Don't look like much, but then they just get kicking and they keep raining, and they keep raining over the same areas. Just to give you an idea, for Lafayette, we received 15 to 25 inches of rain in 36 hours. At my home, 21.5 inches in 37 hours, which had 2 to 8 to 9 inch rainfalls. The last hour of the event, the 4 inches that we got in 1 hour in a slow moving storm, put me from being 2 inches in my personal house from being dry to 2 inches of water in my house. So I'll talk a little bit more about that as well. Quick look at the radar. I don't want to slow us down too much, but this is what a non-tropical disturbance looks like. As you can see, a broad low pressure circulating over eastern Louisiana, and then it gradually drifts west. It was only moving at 1 to 2 miles an hour, or nearly stationary, for about 48 hours. So we saw the heavy rainfall, repeated rainfall, radar reflectivities I've never seen before, and motion of storms over the same areas, like just putting a fire hose pretty much on South Louisiana. So you look at climate change, and I'll make this point a little bit later on, but certainly this was part of, more than likely, there was a good climate signal in here that the latest state of the art is being able to go through the statistics and trying to weed out where has climate contributed to this or not. So this is the rainfall hotspots, and you could probably connect the 2 purple areas over the Chaffalay Basin. We don't have good observing information there, nor do the Dopplers estimate the rainfall there, but you see the hotspots over toward Baton Rouge and then over toward Lafayette. If you're looking at what the return period is on some of these, this rain event in particular, it ranged between a 500 and a 1,000 year rain event. And that's based on what we have culled over the last 100 years on rainfall events and rainfall rates and over rainfall periods. But I'm going to say that this has got to change. A lot of us may have seen this. This is the precipitation distribution server. It used to be called the Rainfall Atlas when it was in paperback, but has been updated for Texas, but not Louisiana. But we look at these rainfall, 2-day, 3-day rainfall rates, and we're squarely in 500 to 1,000 year time frame. And I will submit that what we use as reference points for 100-year rainfalls are probably 40 to 50% underdone based on the last 30 years. And I think there is going to be an update on this, but there's going to be a lot of fighting, because this is what people build on. This is what engineers count on. And the higher you make these numbers, the more costly it is to build retention ponds, that sort of thing. Personal side note, this is my front door. Bless my wife. She put a couple of sandbags by the front door, but will it work? No, not unless you have the entire house bagged all the way around. So this is the result 2 days later after the flood. And I highly recommend, personally, if you have wall-to-wall carpeting, take it out before you flood, because it weighs 100 pounds per square yard. I actually weighed it, and it is very hard to drag out. So, and unfortunately, we see a high chance of repetition. Then we get into hurricanes. Hurricane Harvey was a tropical depression, and within 44 hours, and this is our problem on the Gulf Coast, within 44 hours, it was a high-end Category 4 storm. So we only have 2 days, if something develops in the Gulf of Mexico, to have these super intense storms making landfall. Harvey, and then Harvey on top of that, was slow moving in the new paradigm of climate change, where it dumped upwards of 60 inches of rain in around the southeast Texas area. So that was the rainfall. And we did get about 20 inches of rain over toward western Louisiana in that system, just on outer fringe rain bands. Then I submit next year, Hurricane Michael. Hurricane Michael, inside of 48 hours, went from a tropical depression to a Category 5 storm, making landfall by Panama City Beach. So another storm in the Gulf of Mexico. Let's see if I can advance the slide. Then we get to the 2020 year, where we had this record season where Louisiana was in the cone of uncertainty, or cones of uncertainty, for 29.5 days. 6 tropical systems, including a couple of tropical storms. We had Laura, Delta, and Zeta. All were major hurricanes at one point, Zeta and Laura making landfall as major storms. And this is a plot also of sea surface temperatures, and notice the darker reds, that's your hotter water. Not only are we seeing the Gulf of Mexico and the Northwest Caribbean being hotter on the surface temperatures, but those temperatures above 80 degrees that fuels tropical systems are also getting deeper. We're finding that this water is, 2005 was as deep as 800 feet. In 2020, it was on the order of 500 feet. And we had storm after storm, and the traditional thinking was, oh, well, you had a storm, you had Laura go through there, it's going to cool the ocean water, and it does a little bit, but there's so much water, warm water down below, that even when you get upwelling, we were still able to support Hurricane Zeta into November. And there were a number of other factors that went on outside of climate that made it a very busy year for us in the climate world. This is one of my favorite graphics. I kind of made the computer crunch all the tropical systems for 2020. And you can see all, and I look at this graphic and I see lots of unpaid overtime. So, but the lowlights or highlights, you had Hurricane Eta and Iota, Category 4 or 5 storms striking nearly in the same location in Nicaragua. And then, of course, all the Gulf Coast activity highlighted or lowlighted by Hurricane Laura. And we're going to spare you all the damage pictures. And then Hurricane Delta, that nearly came within 12 miles of where Hurricane Laura made landfall, and then Hurricane Zeta as well. And then we're in this new world where it seems like we have 2 storms threatening at once. And this is where we were before Laura came in. We had to deal with Marco and Laura, and then trying to message what's going to be the greater threat. Very, very difficult. We used to say this is Hurricane Laura, peak wind gusts. Lake Charles here in the pink, showing those peak gusts in the 135 to 140 range. We used to say, I mean, when for the first 20 years of my hurricane experience, flee from the water, meaning storm surge, or if you're in a flood prone area, but not from the wind. I think we have to change that thinking. Here's the hurricane surge with Laura, that surge penetrating some 20 miles inland and covering a widespread of better than 20 feet of water, 18 to 20 feet of water in that hot pink area crossing Highway 82. Then we get into Hurricane Ida this year. Again, a high-end Category 4 storm, doing a tremendous amount of damage in Terrebonne and Lafourche parishes. This was very close to a 5 at landfall, may eventually get classified as a 5. There were some pressure readings that need to be verified, some wind gusts that need to be verified. And notice what's popping on your screen is Laplace, kind of in the center of your screen. That's on the western fringe of Lake Pontchartrain. Tremendous storm surge, not only along the coast, but coming in from Lake Pontchartrain. And this is right outside of Laplace at Frenier's Landing, to show you a time lapse. I got this from Mark Sudduth with Hurricane Track, showing you how the storm surge comes in before the worst weather comes in. So the water's already up a foot to foot and a half here. And you can see how it goes as the day progresses and we get closer to the evening and the storm is making landfall. You'll see a truck and a van kind of pop in from the left-hand part of your screen. But this is what we're dealing with along the coast and inland in unprotected, unlevied areas. And this is just the beginning of what we're going to see. There you see the van with a trailer. I don't know if it looked like people were trying to do something there, but then the water just got higher and higher. And then unfortunately, because I used this video, the owner asked me if I could go find the video camera, because the video camera eventually got swept away and into a tree. So quick and dirty here, what's going on? Well, we're seeing CO2 increase, and this is a plot of CO2. We get our actual observations from Mauna Loa and from the South Pole, daily observations. And we are right now at 415 ppm as of today. This graphic is roughly 2017 fresh. But I like it because it shows how CO2 has been increasing in an unnatural form. And we know CO2 is a heat trapping gas and it's warming the planet. So you go further back and we can get this data from tree rings, ice cores, and we are in very uncharted territory. Over the last 800,000 years, there's a new study ongoing down in Antarctic now that they're looking to get back to more than 1.5 million years. Now, remember, we as humans and species have been on this earth for roughly 50,000 years. So this is going to be completely different from what we have seen anywhere on the globe. So I'll spare you this global warming anomaly just to keep things moving along. Let me go to the next slide, if it'll let me. And this is a kind of, you may see this, these are climate stripes representing what our climate has looked like compared to the 20th century norm. And on the right-hand side of your screen, present day, and it's just plain old red. So we know we're heating up. And where is that heat going? It's going into the oceans. We're seeing the oceans getting hotter and hotter, and that supports more atmospheric moisture, and it supports also, and people don't realize this, that sea level rise, not only from melting of interior glaciers, Greenland and Antarctic, but that hotter water also expands. And what we're finding now is that the sea level is rising, but rising at a faster and faster pace. Every time we look at it, it's a faster pace than when we looked at it 2 or 3 years earlier. So this is kind of the canary in the coal mine showing up, where we're going to see major ice melt events on the Greenland and on Antarctic. Some folks and naysayers will say, well, Antarctic's growing ice. Yes, in the center of Antarctic, there is growing ice, but the net loss for Antarctica is in the trillions of gallons every year. So I just thought that graphic was good. And that sea level rise is not uniform across the globe. And here on the shallow Gulf, we will feel it more so even faster. So what are we seeing? We're seeing the risk of similar events, and this is just taking that August 2016 event. The risk of similar events in the future is 40% greater. I think it's actually closer to 50% now. And the rainfall intensity, and this goes for Oklahoma, this goes for Arkansas, Louisiana, anywhere on the Gulf South, at least 10%. And I've seen studies that go as high as 30%. So 32 of the top 50 flood events have occurred since the 1940s here in Lafayette. Just in the last 30 years, 16 of those have occurred in the last 10 years, okay? So we're seeing the Mississippi flooding more, the Vermilion River, which runs through Lafayette, running more and flooding more. And we see this trend across all of the eastern part of the United States, where we're seeing an increased annual rainfall and increase in annual intensity rates. So finally, to wind down, you know, we look at this map of Louisiana, and this is the way we see it on just about every map you look at, right? But given coastal erosion, given subsidence along the coast, this is what it should look like, with the areas of green being the land areas and everything else is wetlands or Gulf of Mexico. So if we just extrapolate what we have been seeing over the last 20 to 30 years and just look at given the rates that we're seeing right now, we can use some of these case studies that indicate at least 2 to 3 feet of increase of sea level by 2050. It's not like it's so far down the road. It's in the next 30 years. And then you're looking at the higher end ranges going through 2070 and then to year 2100 by the end of the century. It's going to be crazy. So this is the way the coastline, the way the map will look given the current rate that we're seeing by 2050. This is the conservative or lower end estimate. 3 foot is probably what we need to plan for. And how do you plan for this when you have power lines that you can't bury under the ground that are continually rebuilt, built, rebuilt, destroyed, and rebuilt again? And how are we going to adapt to this? We are going to see, and we have seen since 2005, coastal parishes, population flight into interior parishes of Louisiana. I did a study on that several years ago. This graphic's a little old, but 6 out of the top 10 years, I think 2019 slipped in as a top 10 year and knocking out somebody else, but we're seeing the mean temperatures rising. And in Lafayette and in Louisiana, it's not so much the high temperatures, it's the mean temperature that we gauge. And where are we seeing it? In those warmer overnight low temperatures. So we're seeing the Gulf of Mexico, which is running about 1 degree Celsius above normal, actually probably closer to 3 degrees above normal Fahrenheit. So with that expanding water continuing to contribute to sea level rise and coastal erosion, subsidence, we are more and more vulnerable to tropical storm and hurricane surges. So what can we cull from this? Last slide here. The total number of Atlantic hurricanes we think may stay the same because hurricane activity is also influenced by El Nino, La Nina. 2020 was a La Nina year. We were La Nina 2021 early in the year, then it came back late this year, and it may continue into next year, which is a hurricane enhancer. But we're seeing the storms that are going. We might see more upper level share on the El Nino years, which may knock down the number of storms a little bit, but we're seeing whatever storms are going, at least 5 to 10% more intense. And we have case in point, everything I showed you earlier, more rapid intensification cycles. That's when you jump 1 or 2 hurricane categories in a 24-hour period. And we've seen that with all the storms I showed you. Storms are carrying more water vapor. They're moving more slowly. Why is that? the jet stream is being displaced and it's getting wavier and funkier. And that's also feeding into, even though we're seeing milder winters, we're still seeing these Arctic outbreaks because the jet stream now is more perturbed. And you see these polar vortices that break off and make a quick 4 or 5 day shot down to Louisiana. We saw that in winter of 2017-18. We saw that again in last winter where we saw some record cold. And I don't have to tell you about what went on in Texas. Storms are just carrying more water vapor and they're stalling. And that is, bottom line, more prolonged flooding and events and storm surges. And for the Northeast, they're also reaching more high latitudes more frequently. So we're going to see more Hurricane Sandys more than likely impacting areas up along the East Coast as well. And that's my observation, and that's what I call just looking at the trends. And that's, hopefully you can cull something from that. I know this is a multi-state area that we're talking about, but we have to plan for higher rainfall rates. You're going to see higher and more frequent, you're going to see more frequent temperature swings, and they're going to be more magnified. If you just look at the weather pattern, it's just hard to pick out where climate is, but we're seeing the needles going up and down, whether it's rainfall events, heat events, cold weather events. And yeah, you could actually argue, and this might make some people happy, that I think we see more winter weather events because of this wavy jet stream that we might not have. We averaged snow once every 10 years when I first got to Lafayette back in 1988. Now we're seeing snow and ice events once every 4 or 5 years. So I think we're seeing that change as well, but I haven't got the study on that to verify that. So I'll take questions if we have time. I probably went long because that's what we do in television.
Thank you, Rob. No, that was an incredibly dense amount of information in such a short amount of time. So I'm impressed. Thank you so much. I don't see any questions in the chat. And so please do put in any questions if you have them. Unfortunately, Rob can't stay for the entire workshop here today. So if you have questions, now is your chance, but I'm sure that we could also send some questions to Rob after this if there's something that we should follow up on. So Rob, I do appreciate your presentation and you taking the time this morning. That was like I said, an incredible amount of information in a short amount of time. I'm sure it's going to take people some time to percolate and gain wisdom from that. So I appreciate it. Let's go ahead and transition to our next set of presentations today. So this is going to be a short panel of water utilities in both New Orleans, Arkansas, and Oklahoma. And so we're going to start here with Mr. Ron Spooner. And Ron Spooner is coming to us from New Orleans today. He is the interim general superintendent for the Sewerage and Water Board of New Orleans. And Mr. Spooner began his career in 1990 as a transportation engineer in California with the California Department of Transportation, working on various bridge projects in Southern California. In 1993, he joined the Sewerage and Water Board of New Orleans as an engineer in training. He worked in the maintenance and engineering departments, progressing through the ranks of engineer, senior engineer, principal engineer, and chief of networks administration. He spent some additional time in Southern California, it looks like, and then returned back to the Sewerage and Water Board in 2006 as principal engineer in the aftermath of Hurricane Katrina. And he served as head of the network engineering department, chief of engineering, and interim deputy general superintendent. So I will go ahead and pass over the mic to Mr. Spooner so he can talk a little bit about New Orleans.
All right, thank you, Galen. Glad to be here. Let me see if I can share the screen, if I can get that to work, and hopefully. All right, everyone, Galen, can everyone see the screen pretty good?
Yes, looks good.
Okay, well, thank you. And again, welcome this afternoon. Glad to be a part of the presentation. And again, I'm Ron Spooner, the interim general superintendent of Sewerage and Water Board of New Orleans. And I'll talk briefly about the weather impacts on our utility operations. So a very brief presentation, and let me see if I can Okay, so who are we at Sewage and Water Board? We are one utility. We provide potable water, wastewater, and drainage services for the citizens of the city of New Orleans. We're independent. We are an independent public utility. We're a political subdivision of the state of Louisiana that's governed by an 11-person board of directors. And the mayor of our city, the Honorable Mayor Cantrell, she is the president of the board of directors. The Sewage and Water Board, we're not a large agency, sort of medium-sized agency. We right about 1,300 employees under the city civil service system. And the three major utility categories, what we do is water, wastewater, drainage. And water, again, which most utilities, if you're along the Mississippi River, especially in southern Louisiana, that you get your beautiful raw water, as we call it, from the fresh Mississippi River. We treat that water. And we pretty much close to, we have two water purification plants, one on the East Bank as well as one on the West Bank, both combined right at 220 million gallons a day. We got two water treatment plants, wastewater treatment plants, a little over 1,800 miles of a water distribution system. And when we service roughly 136,000 meter customers. So, and then we are strictly funded by customer rates and fees and charges. So that's our basis of our funding. And wastewater, again, we return the clean effluent back to the Mississippi River. We have about 1,600 miles of gravity sewer between force mains collection systems, 84 plus or minus pump stations and lift stations, two wastewater treatment plants, and again, funded by rates. And then one of our largest components and one of the other components is our drainage system. So as everyone knows, the city of New Orleans, this metro area, we are below sea level. A large portion of the city is below sea level. So, you know, when rain comes, you get a little nervous around here. But one of our main functions outside of potable water and wastewater is to drain the city, to make sure we have adequate drainage, to drain the stormwater from the city that's roughly 50% below sea level. So the drainage system, consists collectively of about 200 miles of canals, culverts. We have 24 pump stations with a combined capacity a little less than 51,000 cubic feet per second. So, and it's a shared responsibility between the city of New Orleans and the Sewage and Water Board. And the drainage system is funded exclusively via property tax millages. So what are we facing today as a utility? As many utilities are aware, is aging infrastructure. That is one of our biggest obstacles that we face on a daily basis, is an aging infrastructure. Not only just an aging infrastructure, but it's the limited amount of funding that's available to replace this aging infrastructure, to rehab the aging infrastructure. So, you know, that's a chronic challenge. And then, as Mr. Robb indicated earlier, the meteorologist from Lafayette, which gave a very good presentation, the acute crises that we face, especially from June to November timeframe, that's hurricane season, and everyone gets a little nervous, especially around the southeast Louisiana portion, you know. So, but we have these severe weather events that we have to deal with. And lately, and I'm saying lately, the last 3 to 4 years, maybe 5 years, is what's normally be a normal afternoon rainstorm, afternoon shower. These showers are short duration and very intense, and they can drop quite a bit of rainfall in a short period of time, which leads to localized flooding. So those are some of the challenges that we face as a utility. Going into our chronic challenges as we at SWEPNO, and then go to the next slide. Spoke earlier briefly, aging infrastructure. That is, if you take a look, and it's sort of hard to see, but this is just a snapshot that's on the website relative to our water system. We just want to show the age of our water mains in the system. So, you know, the Sewage and Water Board, 1899, the Drainage Commission came through, and in 1903, we combined with the Sewer and Water Commission to combine the Sewage and Water Board. As you can see, that top red box, and I'll put my little arrow right up in here so we can see, is that first 20 years, 1900, 1909, we were booming. You know, the city of New Orleans, that early 1900 was the largest city in the South, without a doubt. So 34% of our water main, our infrastructure, was pretty much constructed in the early 1900s, prior to 1920, you're going up to 1940s, another 13.6%. So that first 40 years of the major development is roughly 48% of our infrastructure was constructed in the city of New Orleans. From the 40s to the 70s, you go to about another 45%. And then once you get to the late 70s and the 80s, we start to, the aging infrastructure starts to catch up with us. And as you can see, this range here to 6.4%, a lot of that is with replacement and rehabilitation. And then when you look into the 20th century, or the 21st century rather, you can really see 0.9, and that's collectively we have probably more than that, but right about 2 to 3 miles a year, based upon the funding that we are replacing water mains. So that is a huge challenge in itself that we have to deal with, this aging infrastructure, and it's not getting easy. So this is nothing new. This is happening around the nation with other cities. So talking a little bit about climate change, and as I mentioned earlier, the more intense rainfall. So, we've observed roughly a 5 to 10% increase in an annual precipitation lately. So this line here, on average, right around here, we average around 60 to 63 inches of rainfall a year. We've been actually collecting our own rainfall data at our various drainage pumping stations. Probably, we have our records go back since 1925, 1926. So we have quite a bit of rainfall, and that's what we can see based upon that data that uses a baseline. The rainfall events are shifting more to an intense but less frequent, these less frequent events. And what happens is you have these intense storms, and it just really pounds the area. Sometimes you can get 3 to 4 inches of rain, that rainfall intensity, in a 15 to 20 minute period, and it will flood. And our system is not equipped or designed to handle that type of rainfall. So again, the heavy events are becoming more frequent, but the heavy events aren't coming more frequent for that way, but the average events are becoming heavy. And that's a key point, because again, as I mentioned earlier, these afternoon rain showers, they are really as if sometimes the pounding the area. So I wrote some notes here that this year alone in 2021, this was our wettest spring probably we had on record for the Metro New Orleans area. And up until Hurricane Ida, Ida came through September, we've averaged close to 80 plus inches of rain in a year. That is really phenomenal for the Metro New Orleans area. I mean, that is rare that we would have a rainfall, cumulative rainfall that high. So again, it is quite high, knowing the average is right around 60 to 62. And as a case in point, this 80 to 81, you're looking at, I think I Googled it, and it was Honolulu, Hawaii, where they have an average rainfall in that amount of the 70s to 80s a year, easily within 80. So what are we doing to mitigate, our utility infrastructure issues we have, and to build more resiliency into the system? And then what you see here is as part of our Water Hammer program. It is one of our many programs that we've started constructing post-Katrina. I'll talk a little bit about that later. So and again, our Water Hammer, consists of, this is one project, and as you can see, we were glad to have President Iden, the Honorable President Iden, come through here this past spring to visit our water plan in preparation for an infrastructure bill that was signed this past last week. So that's a good thing. So we've constructed these 2 towers for more resiliency, to address Water Hammer, and to really protect the drinking water system from power losses and pressure drops. So again, that's, this is part of phase 1, and this Water Hammer program is part of a 3-phase approach, roughly estimated right at $100 million. This is one of 3 programs that we are working through. The first one was the HMGP program, a hazard mitigation grant program. It's roughly right at $150, $160 million. A lot of that was post-Katrina. And then we were also a new program, some of you may have heard of you within Zara, what we call our West Power Complex. And that's for us to be more resilient, to be less reliant on some of our old power turbines, and more on the hard infrastructure from the local utility, from the transmission lines, with the new backup power plant. So again, that's one of the mitigating measures and resilient projects that we're working on. So again, as far as acute crises, and I will talk just briefly, Rob talked about Hurricane Ida, and a little bit from a utility standpoint of view. Hurricane Ida. Again, that was quite a storm that came through, a very strong Cat 4 storm. And it was interesting to hear what Rob indicated that they're going to do some analysis and maybe around this winter it may be to a low grade Cat 5. But even in itself, you know, for a strong Category 4 storm to come through the southeast, some parts of southwestern Louisiana, is a rarity and just phenomenal. You know, and that's on top of the nervousness, the increased anxiety this community is with, because, you know, everyone had Hurricane Katrina, you know, pretty much on the 16th anniversary of Hurricane Katrina. And it's sort of like, oh, it's a flashback. But, you know, we made it through. And not just, we had a few bumps and bruises within the metro area. But one of the interesting things that we felt that was unprecedented with this storm was the power outage. This was a high wind event. We did have some rainstorms, some heavy intense rainfall, but the wind, it really just sort of devastated the overhead electrical distribution system. Even from a SWEPNO standpoint of view, and I forgot to mention early on that we actually generate our own power. And let me take my notes back, because part of our aging system, I was saying to get my notes, is that in order to run our what we call Old City drainage area drainage system, the original system in the 1920s was built on 25 hertz power. Believe it or not, we still generate 25 hertz power to run those 25 hertz pumps, what we call in Old City drainage area. And we're sort of like a little small and medium sized power plant where we can generate. We can generate literally close to 90 megawatts of power. You know, that includes our redundancy and our conversion frequency changes. So the 25 hertz power alone, we can generate up to 60 to 65 megawatts of 25 hertz power. We need about 40 to 45 megawatts of power to run our existing 25 hertz drainage pumping station. The rest is 60 hertz. So it is an aging system. And what I mentioned, one of the projects that we have on the horizon is the West Power Complex that will modernize our power plant and utilizing in phase 1 frequency converters, convert 60 hertz power to 25 hertz power so we can still operate our 25 hertz pumps until we actually upgrade those pumps, which is phase 2, which is 6-7 years on the road, to 60 hertz pumps. So back to Hurricane Ida, again, the outage, which is unprecedented, 8 to 10 days, and it had a really pretty profound effect on the metro area. So as with Sewage and Water, as well as the other local utilities, you know, we lost our I call local sewer pumping station, little small sewer pumping stations around the localized neighborhoods. So those were lost. We had some unanticipated problems with our own backup power. We actually ran our system on backup power for literally 7 to 8, almost 9 days straight. So that was pretty much. And then communication disruptions relative to our SCADA systems with power outages and all that. So Hurricane Ida did expose some weaknesses within our system, and we are improving upon that post Ida. So, you know, going into, and this is pretty much the last slide, but the what I call the post-storm operation. So this photo, what you see here, is 9:30, 10 o'clock Sunday night as Hurricane Ida came through. We went directly into post-storm mode, you know, ops, and that's really something that we had to do, because once the storm passes through, you have to get the area back to normalcy in some form or fashion. Took a little while. We had issues that we had to deal with our state and federal government agencies, with EPA and LADEQ, relative to the discharge of untreated sewage from our wastewater treatment plant because the backup generator and the power went out. But one thing that was a blessing for this utility is that our potable water remained safe. We did not lose a water purification plant throughout the duration. That was just a blessing in itself. We were one of the few utilities for a week after the storm that we were able to supply potable water to whoever was interested. In many hospitals, certain critical facilities, that we actually provided that potable water from our facility to keep them operational. So again, nice quick brief. Just want to talk briefly about the utility challenges. based upon weather events. And Ms. Galen, I will turn it back over to you, standing by for any questions, and you can take back control of the screen. Thank you.
Thank you so much, Ron. That was very interesting. I think everyone had their eyes on New Orleans, and that's as someone who doesn't live in the area, that's always where my eye goes. So very interesting to hear about all the impacts that have been going on. So thank you so much for that presentation. We will take questions at the end of the 3 presentations. So we've got 2 additional presentations to go. So please do enter your questions in the chat box when you have them, and we will get to that Q&A shortly. So next up is Linda Smith, and Linda is the Sustainability and Facilities Manager for Central Arkansas Water. She has a Bachelor's of Science in Chemical Engineering from 1984 from the University of Arkansas, and 37 years of engineering and sustainability experience. And she also has 11 years with the U.S. Green Building Council, so she's well versed in all of these all the intricacies of what we're talking about today. So I will go ahead and hand it over to Linda. If you want to go ahead and share your screen, you are able to do that.
Thank you. I so appreciate being located in the agenda today between Louisiana and Oklahoma, because that's where we are, and we will reinforce what you heard before from New Orleans, but you'll also see how we immediately fit into what is going on in Tulsa. Today, I wanted to start just a little bit about what I do. It's a fairly new role at many water utilities. I really stretch across many departments. I work with our source water, with water treatment, with distribution, with our administrative staff, with the board, looking forward to a net zero plan for our company. Energy efficiency, optimization. I think about waste every day, electric vehicles. And the photo you see there is breaking ground and the construction, which is currently happening, of a 4.8 megawatt solar field that will provide about 20% of our utility demand. Just a little bit similar to what you heard before, to place who we are. We're just a drinking water utility, about a 500 square mile area in central Arkansas. 1 in 6 people in the state do get drinking water from us, either directly as one of our current customers or through wholesale arrangements where we're providing many of the suburbs and even into some more rural areas now. We are the billing agent for water, wastewater, and solid waste, so we work closely with those partners. We get about 50 inches of rain a year, and you're going to see several of the charts that you just saw. It's so funny to me that we all think the same way, maybe because we have 3 engineers giving presentations today, several of the charts. We are provided our source water from 2 reservoirs that you see on the map there, that are, one of them about 35 miles from the center of downtown Little Rock, and then Lake Maumelle, which is closer in town. Those were constructed in 36 and 56, and before that we did take water from the Arkansas River. So the risk that we see in Arkansas as a challenge really are all except sea level rise. The extreme weather, both highs and lows, frequency and intensity you heard about earlier. We have flooding, and those folks in Tulsa are just sending it on down the Arkansas River to us. We have intense rain, and we have heavy rain and shifting patterns of rain leading to flooding. We have tornadoes. We have hurricanes coming up from the coast, where we're actually now reaching hurricane level winds in central Arkansas, something that was just always unheard of. Wildfires. Drought has not been that much of a challenge, but may be in the future. And then this disrupted polar vortex that Joan's going to talk more about, pushing very intense cold weather down to us. where we in the past have had maybe 1 or 2 days of snow. It came and left pretty quick and not a strong impact. Now we're seeing it come and settle in a much colder fashion than we're used to encountering here, or that we're even prepared for. So that's something that we're addressing in our risk plans. Today, I'm going to talk mostly about high temperature impact, the way it affects our people more than anything, but also our sourcing and our infrastructure. And really, I think all of these come into play in that if you are a resilient utility looking at what is to come in the next years, how are you planning for that? How is that affecting your capital budget? But really, what are you doing to plan for your workforce impact? So I'll go through quite a few of those. You saw this chart before. This one is the precipitation. And you can see we are getting into that slightly wetter, but not terrible. You know, we're still in that 50 or so up to 60 inches of rain, but we have had wetter and more precipitation in the years since 2010. So true trend. Climate change is when you see a decade worth of impact, and we can definitely see it there. And then this is the one that really makes the difference when you're talking about hot weather and high intense weather, heat index weather impacts of over 90 degrees for a heat impact. And you see how hot and how extended it has been, those really intense years, the high temperature years that we're encountering. And I don't know anyone who could look at this chart and doubt that the climate change is here in Central Arkansas. So one of the things I really wanted to focus on is what we have seen as days that it's really too hot to work. We know that we can't stop working. We need to be out in the field every day, especially with pipe repair and with other required activities, whether that's engineering work or testing work throughout our system. But in the years from 71 to 2000, really just, you know, although it's hot in the summer, we were able to, you know, have between 2 and 10 days where it was really risky for our workforce to be out, and that we had to take some steps to adapt to that. But what we do see coming and what we really are planning for here is a tremendous change in the workforce for work days at risk due to extreme heat. These are heat index days over 90 degrees. So as you can see, if you go from 2 to 10 days here in Central Arkansas, up to 41 to 60 days, the impact not just on that one day's work and overtime for that week, but really the accumulated impact of that on the body, on the physical strength and ability of many of our folks that are out in the field. And not just those in distribution, but engineering, that people like me that are out 2 or 3 hours a day, typically outside. How do we train for that, and how do we prepare for that as a manager in the company? You all have heard this, hottest days on record. That was reinforced in our weather presentation. But the heat index above 100 degrees F, 3 and 4 times increase that we really are looking towards, and how do we plan for that? And the impact on the people of color. Really, you know, our workforce is still 80% men in our distribution department. How does it affect their ability to earn income, to not miss days of work? How do we recruit people who are willing to work outside, knowing it's going to get hotter and hotter, and the less activity, kids don't play outside as much, fewer people are playing sports, and so they're not even training in high school for, you know, 2-a-day football practice to prepare you to be in the workforce. And then, as we've seen in the last year and a half, the PPE impact, you're wearing more gear, you're wearing masks, and how does that impact your workforce? What we think and what we have already seen is more injuries, people that have had their safety glasses fogged up because of masks, dizziness, burns. It's not on this list, but the impact of just surly attitude, working crews together, how do you get past that? How do you be a productive team when it's so hot you're angry with each other all the time? Heat exhaustion and heat stroke would increase. So we are making some changes there. Asthma and allergies, as it's either dustier or we've had more rain and therefore increased pollen counts. You're going to see both of those. And then mosquito and tick-borne disease as we have people out in the field. So the changes that we've really made here and that we continue to make, and as many of you do, we shift our work day as it gets hotter. Usually we stop at 3 o'clock with our crews that are mostly outside, but on days above a 90-degree heat index, we have them returning at 1 o'clock. Well, what does that require? You can't stop the work. You're going to have to send another crew who's going to be on an overtime shift to finish work that must be completed the same day to keep the water on. And so an increase in the overtime and in the size of the crews, therefore the number of employees. We've changed to having just plain cotton t-shirts with a yellow safety vest on to some moisture wicking shirts and combined yellow shirts and stripes in safety. Water-cooled garments is something we're testing out right now. We've used tents. We haven't used misters, but taking a cue from the sidelines of SEC football, misters at some of our sites might be appropriate. And then finally, the acclimatize your workers. We are just doing this for the first time this year, where if we hire a new member of an outdoor crew that we will, and they've worked construction or other outside jobs, then we would, over the first week of work, allow and limit their exposure on hot days. And really, this is summertime acclimatization for us. If you're a new worker and you came to us and we've hired you to fill these hard to fill slots, but you've never worked outside, we really are going to start very slow, 20% time outside. And that leads to some hiring challenges. Where are we going to get folks that are ready to be outside in weather to come? The larger crews, hiring challenges, we are increasing our safety reminders and checks. We've added additional employees to our safety team who visit crew sites and really help us there. And so as I think now about our watershed, I really, the second area of high temperature impact is our source water. Are we going to have enough? We have a very shallow reservoir, less than 25 feet in most spaces, but we need to protect that well. High temperature is a major concern in ways you would not expect. We own quite a bit of the land around our reservoir, and we are acquiring more. We have a watershed protection fee that generates about $2 million a year, and we've issued green bonds to buy land. There's increased pressure from development all around our main reservoir. Everybody wants to live on a lake. But we really need to protect that land. So we're buying it and we're working with partners like the Nature Conservancy really to protect it. But the impact that you may not think about, that southern pine beetle up there in the corner is really attacking and increasing the devastation of forests in Arkansas, and high temperatures are not going to help that. Those dying trees are going to affect our reservoir. We have continuing issues as the temperatures increase around us for sediment, for carbon, for algae, and the hurricane effect. As we get these hurricanes up from the south, we get, instead of just a gradual mixing in the fall, really the high dollar impact of a reservoir that's mixing, that then we're increasing our treatment and water chemicals. And so we are managing our forests better than we ever have. We are doing prescribed thinning and burning, purchasing land, and partnering with many of these folks that care about the water as a recreational opportunity, but also help us then protect. We've seen a shift of, I put up here October production. Typically, we're running 63 million gallons a day in water, but we're seeing that shift where we're still hot going into October. And so we are seeing peak days in October in the 72 million gallon range. Rather than those that October was when we started to get a little bit hotter from the hurricanes and weather, and we're just still seeing the demand continue. And so all of that is just dollars. Every one of those is just more money. The requirements for infrastructure costs that are underfunded are impacting us all, and you heard a little bit about that. I think the thing that's different is now it is climate change has an impact and is included in our strategic plan, in a climate action plan that we have. We're taking input from workshops like today and from manuals that we're getting from our industry. And we're really talking about it a lot more from the level at the board through all the senior management and down into how does it affect my overtime or the number of people I'll be working with outside when it's really hot. Some of the efforts here are those that you're all doing across the South. But protection of the watershed is very visible for us and one that we're very proud of. Joan's going to talk about winter lessons learned, and I just had to put up a couple of transition slides. The winter event that she'll mention had a huge impact on us. We did not lose the ability to provide water, but we sure were a little worried about it. You know, it started on a Sunday, and by Thursday we were empty at most of our clear wells, and so it was a true emergency time for us. Things that we don't think about in the South. We don't have enough treatment chemicals on hand to run at a peak summertime in the winter. We don't have road crews. We rely on the city to clear the road just to get chemicals delivered when we're running a peak demand like that. So a couple of slides there, but really just to wrap up, we believe that the climate countdown has begun here in Arkansas, and we are preparing for it as you are. But heat is going to be one that we really have to think about all the time.
Thank you so much, Linda. What a great juxtaposition, I think, from what Ron talked about in New Orleans, and a very good segue into what we'll see with Joan's presentation. So I'd like to invite Joan to turn on her camera and take control of the screen so that we can go ahead and get to the presentation for the city of Tulsa, Oklahoma. So Joan is the asset manager for the city of Tulsa Water and Sewer Department. And she has 22 years of experience with this department as a process engineer, superintendent, and water and sewer infrastructure planning. As the asset manager, she has developed and implemented the asset management framework for Tulsa's water and sewer department. The asset management framework is designed to meet their strategic objectives to operate, maintain, and rehabilitate the water and sewer assets safely and efficiently across their life cycle. And Ms. Gausvik is a graduate of the University of Missouri-Rolla, and she's a professional engineer in Oklahoma and Florida. So I will go ahead and turn it over to Joan.
Thank you, Alyssa. I titled my presentation today, The Winter Freeze of 2021, a case study, but I'm probably going to talk a little bit broader than that. So I'd like to speak briefly this afternoon about the Tulsa Water and Sewer Department and our response to freezing temperatures last winter. Just for a little bit of an orientation is Tulsa is located adjacent to the Arkansas River in northeast Oklahoma. Northeast Oklahoma is generally called Green Country. It is the 47th largest city in the United States, and with the 2020 census, metropolitan area has just reached over 1 million people. City of Tulsa has about 700 water and sewer employees and about 3,600 municipal employees. We've talked about weather a little bit, and weather in New Orleans, weather in Louisiana, weather in Arkansas. When I looked for, kind of how would you describe Tulsa weather? Variability is really the word that comes to mind. That although our overall climate in the Midwest and on the coast is predicted to be warmer, Tulsa's weather is just very unpredictable. We experience seasonal weather changes often within a week or two of each other. We can go from being very warm to very cold. And I think what we're just going to be seeing is that we're going to be warmer than normal. We're going to be drier than normal sometimes, wetter than normal, or snowier than normal, or colder than normal. And I think it's just going to all boil down to the fact that our historical data is not going to be a very good predictor of what is future normal. Just a little bit about Tulsa. The goals of the City of Tulsa Water and Sewer Department are pretty simple and straightforward. First and foremost, we strive to provide high quality drinking water and wastewater services to every customer. We are planning for the future and working to become more resilient and more sustainable. And we are really trying to, safeguard the public and the environment and are always looking for ways to improve, become more efficient, control costs, and become more resilient. Just a brief overview of our assets. We're a water and sewer utility. So our water assets consist of 2 large water treatment facilities with a combined capacity of 220 million gallons. We have about 2,300 miles of water distribution lines. We have 3 raw water supplies. I sound like Bugs Bunny. And 2 high hazard dams and more than 4,000 water assets. That doesn't include our pipeline. Our wastewater system is also very important for maintaining our quality of life. I kept telling everyone this year is that instead of a day without water, we should talk about a day without wastewater services and see how interested people are in the services that we provide and what it would be like without them. But we have 4 wastewater treatment plants with a combined capacity of 103 MGD, about 2,000 miles of sanitary sewer, and wastewater is much more equipment intensive, and we have almost 9,600 equipment assets in our wastewater system. Now in 1986, Tulsa had a big flood in 1986, but in 1986, Tulsa was one of the most flood-prone cities in the United States. And today, or in 2021, Tulsa received a Class 1 certification from FEMA as being one of the most flood-resistant cities in the country. We're one of 2. When we have maintain a multi-hazard mitigation plan. So when Tulsa updated their mitigation plan in 2019, we considered a wide range of natural hazards. And they included the ones that we always think of for Oklahoma: tornadoes, hail, lightning, extreme heat and drought, the 2019 flooding and levee failures. But winter storms also ranked very high in our concerns and in our multi-hazard mitigation. So the February 2021 comes along, and when we looked at severe winter storms was a high probability, and Tulsa completed their WIA planning in 2000. And we evaluated winter storms, and our historical context was the ice storm of December 2007, and it impacted a large amount of Tulsa. At the height of the storm, 78 of 100 every 100 electric utility customers didn't have power. But there were a couple of things that were really different. Water demand during this storm was really low. So our average winter water demand is about 84 MGD, and we were at about 65. And temperatures were relatively mild. So the ice didn't last very long that had caused all the problems, although it did take PSO quite a while to put the system back together. But the February storm was really different. It was the 4th coldest February on record, and we spent 11 days below freezing. So even the high temperatures didn't get above freezing. So our crews are not used to putting water lines back together in multiple days of sub-zero weather. Record lows were set on February 15th and February 16th of -7 and -13 degrees. All of this resulted in, so our very cold temperatures resulted in a lot of frozen and broken pipes. We had a record number of 450 public water main breaks. I'm sure people are going to be talking about that for a long time when they, probably when they're looking at what people shouldn't do. We also had a lot of private water service failures, fire lines that were broken, buildings that people didn't realize their water was broken in because they weren't occupying that space at the time because of the pandemic. We had a lot of service lines break, a lot of water breaks in people's homes. We responded to over 1,000 emergency shutoffs during this time frame. So all of that, we look at just kind of our water service, and we had more than 5,000 customers impacted directly by a water outage, including 514 businesses. And our normal KPI for returning water to service is about 4 to 6 hours. And we had many customers that were out 24 hours to 48 hours just in, getting crews out there. Had all of our city water distribution crews working. We had 11 contractor crews working. Our contractors working with multiple crews, trying to repair the water main breaks in a timely fashion. Another real unprecedented impact of this demand is because of the large number of both public and private water line breaks, is we had an unprecedented winter water demand. Tulsa's average summer water demand is 175 million gallons a day, and we had water demand peak for about 48 hours at 180 during the winter storm, trying to maintain pressure on the system. A lot of operational issues as a result of this is our reservoir storage was depleted. We had increased pumpage. We were pumping very, very cold water at one of the plants, just barely, not frozen water. We also had a raw water supply line down to a plant to do maintenance. Winter is usually the perfect time to do that. But this created that plant was receiving raw water out of the terminal reservoir, and they emptied the cell where the raw water intake was, and they had rented pumps or borrowed pumps from the Corps of Engineers pumping over one of the interim berms. The reservoir has 3 cells, so they had to pump water over the berms to get water to the plant. So Tulsa was able to supply water during the entire event. It got a little dicey for a while. And then, so after the event and, pretty quickly after the event, everybody starts talking about what you should have done. And, a lot of times more frequently what you did wrong. So hindsight's 2020. But after a significant event, there's lots of questions regarding what we did, what we should have done, what we can do next time. So we really sat down and mapped all of the breaks from the event and put that on our distribution system. And we can see, from the map here that, they're concentrated. This is the older section of Tulsa. This is also where we have a lot of our cast iron water lines. So a lot of our breaks and our cold weather breaks were concentrated here. So we've got a map viewing the event and, looking at where all of the water lines and where our breaks were so that we can learn from this. We also kind of mapped how the event unfolded. So this is kind of a time plot of our water main breaks, the average water temperature from our AB Joule water plant, and our minimum air temperature. And what you can really see from this event is as the winter weather started to come in and as the air temperature fell, is our water temperature also fell drastically. And this red line on our graph is freezing. So delivered water temperature from AB Joule was just above 32 degrees for about 5 days. And that correlated with the huge number of breaks that we saw in that same time period. So that was certainly the worst of the incident. And as the air temperature and the water temperature started increasing, and again, we got over that sort of magical spot of 39 degrees, our water main breaks went back to what is more of a winter normal. So we basically, we have really dubbed this as a cold water event. Obviously, cold water is not something we can do a whole lot about. We're a surface water treatment facility. We use terminal storage reservoirs that are not very deep. So we're looking at ways to, kind of monitor this, predict this, and prepare for it in conjunction with addressing some of the most vulnerable infrastructure. So as we, one of the things when I sat down and I presented the first presentation to my board after the event was I really told them that this was a test of our water distribution asset management plan. So about 3 years ago, we had put in place a risk-based asset management plan to prioritize the replacement of our water distribution mains based on overall risk. And this plan defines the methodology for identifying risk and identifying rehab priorities. And it really prioritized our cast iron water lines. Part of the problem and the ongoing commitment that we have to make as a water and sewer utility is that our cast iron water lines make up about 50% of our inventory. So it is an ongoing process. But we did notice, and as I showed you on the previous map, that a large percentage of the cold water breaks occurred in our small diameter cast iron water lines. So that reinforces our program that they are a priority for replacement. And this last slide really here this is showing our water distribution risk maps. And at one point I had mapping that I could overlay the breaks on this, but the area with most of the breaks was right in here, right in kind of our midtown area. And as we can see, as we look at the pink coloring, the red coloring, even the orange, this is all cast iron water line that was constructed in the 40s and 50s. And like a lot of things we built right after World War II, is we were building so quickly and there was such demands on material, is that some of this is not as robust and is failing before newer and older water infrastructure. And just, as we kind of to wrap up is, some of the things that we want to learn from this event, and as, and basically, just like asset management is for resiliency, for climate change, is we want to implement a process of continuous improvement. We're looking at, in addition to our capital investments for infrastructure replacement, we have to make sure we're prepared to respond to future events. And some of the things that came out of our after action reports was correlating water temperature trends and local weather forecasts. So with this event, we definitely were monitoring the local weather forecasts, but we were thinking of, our impacts would be people getting to work, roads being icy, just kind of the normal winter weather impacts. We really didn't, although we see a rise in the number of breaks, during cold weather, we really were kind of, hustling during the event to, get enough crews, get enough manpower, get enough equipment, get enough supplies to be able to respond. So we're looking at, just as part of our response is, identifying our emergency repair contractors at the beginning of the season, negotiating the contracts and the price list, identifying how we're going to contact crews, when we're going to put them on standby, et cetera, so that we are prepared to respond. We're developing standard operating procedures for emergency contract work, so that everybody will have the same set of procedures they'll be working with. Establishing lines of communication, We're also looking at a more efficient methods to turn water on and off when we have to take customers out of service, and also communicating when when water is turned back on as much as anything. We had contractors complete work um, and then didn't know that they were done and they had gone on to the next job. So really working on communication. And kind of one of the last and most important lessons learned from our event is just the communication with our customers. And I think this is going to, an event shows you with just, the particulars of a storm or a hurricane or whatever. I think even as we look at communicating change to our customers, it's going to be important how we do that. It's like playing telephone. Everybody doesn't get the same message. So a lot of times we can think that we're being very clear and our customers have no idea what we're talking about. And one of those things was the state kept issuing voluntary boil order advisories. And customers have no idea, you know, when you get an order that's voluntary, should I do it? Shouldn't I do it? What if I don't do it? Am I, is my water safe? Isn't my water safe? So really, we're trying as we go into our, next winter, but this pertains to whether or not we're responding to a winter storm or a summer storm or any sort of outage is, just to have clear messaging, communicate with our customers. In this event, it would have been nice to be able to teach them how to, find a leak, how to report a leak, potentially how to, protect their own property. What does it mean to drip water? How much should I drip? Where is it, finding the shut off in your house ahead of time. You don't like seeing those, pictures of the whole ceiling fan is covered with ice because somebody didn't know how to turn their water off. So I guess to, kind of wrap up my slides and where we're going is it's a process of continuously learning, continuously improving, continuously adapting. I think the one thing that we can say for certain is things are going to change.
I appreciate, thank you. And that was very, very interesting and I think a good overview of kind of the other extreme from what Linda was talking about. So, and something that I have heard over and over again from water utilities this year is their concern about ice and about the implementations of these ice storms. So it's incredible how 1 year of bad weather can just focus everybody's attention on these issues. So I appreciate that overview. And I wanted to just turn to some of the questions that we've been receiving. Again, if you have any questions, please do put them in the chat. And we will start with a question from Eric Lee. The question, and it doesn't look like it's posed to anyone in particular, so Linda, Joan, or Ron, please jump in. It says, have any of these events caused these utilities to update their risk and resilience assessments?
I know for us, it's Central Arkansas Water, it has, like I say, we really have never thought of a winter extreme storm. And even immediately the next week when we were reviewing our plans, somebody said, oh, that'll never happen again. And I said, oh, you're wrong. We need to plan for and be ready for increasing in frequency and intensity of these events. So yes, we are updating.
Ron or Joan, did you have anything to add to that answer?
Well, I mean, I think, as we have looked at our risk and resilience plans for Tulsa is, I'm really trying to approach it from this process of continuous improvement. So although the rules only say you have to update that plan every 5 years, it's really as events happen that are maybe different than your assumptions. So, like this winter event was different from our assumptions for a winter weather event. And so it's important for us to go back and look at those assets and those functions that we thought were vulnerable to winter weather anyway, and see how we would change that, how we would review our approach and what we might need to do differently. Because as I kind of said, I think the one thing we can really count on is that things are going to keep changing, and that we're going to see things that we haven't seen before.
Absolutely. Ron?
No, the only thing I piggyback with the other two. One of the things we've learned from Hurricane Ida, which was quite unique, was the although it was a voluntary evacuation, was a mandatory evacuation, but there was a large number of residents in the metro area that did stay, and that was because the storm came up so fast, it was hard to do a mandatory evacuation. But one of the challenges that we had faced with was that normally with an evacuation, when you have a mandatory evacuation, then you don't have to worry, I would say, as much of dealing with the citizens and the services. But in this case, we had a good 40, 45, 50% of the folks who stayed in town. And then with the challenge you had to deal with is to make sure that we were somewhat, how can I say it, providing some service. It wasn't 100%, but we can provide about 50 to 60% of the services to make it somewhat livable. So that was one of the lessons learned. And then the other lesson learned, what I've indicated earlier in the presentation, was the duration of the utility outage. That really opened our eyes quite a bit. Because normally a hurricane would come through 2-3 days later. If it's not that bad, then you're back to normal. But it was sort of like a complete blackout in the southeast Louisiana region, and that was quite unique. So we're taking a look at our resiliency and some of our backup plans to see how can we weather a duration that would go longer than 3 or 4 days, and that's quite a challenge, So it's not that easy, but it's something that you have to take a look at because it's as if these storms, as Rob indicated earlier, you have 1 and 2 is back to back or 2 simultaneously, and you have to deal with them continuously, and dealing with the fact that the public continues to phones are going off, but the public, more of the public is continuing to hunker down, hold house generators. They say, hey, I got a hold house generator, I can make it. But as without proper sewage or water, it's going to be difficult, even if you have a hold house generator.
And I would add that the frequency of these and the longer recovery time means even when we have mutual aid and we've sent some of our portable generators out of our service area to help others, then we're calling them back because we need them back, and they're still having, as Ron just said, an extended time where they really needed them. And so I think mutual aid comes into play. And we won't have 3 or 6 months to get our equipment back from someone we've loaned it to.
Yeah, and that's a good point you made, because with Hurricane Ida, because of the widespread utility outage, generators were very hard. I mean, extremely hard to come by. It's just unbelievable. GOSEP and FEMA were very amenable to do as best they can. They had a hard time finding generators due to the fact that the area of devastation outside the levee protection system was so large. Terrebonne and Lafourche parishes, they were just devastated. And so that's another thing we're looking at, is how can we somewhat, I wouldn't say limp along, but limp along with generation insights, generating equipment in place at some of our critical facilities, so we can sort of limp along until the overall utility grid comes back up. But man, from Arkansas, you made a very good point, Ms. Linda Smith, that that was quite a challenge, just getting a 200 kW generator. I mean, it was hard enough to get a 2 meg, but a 200 kW was just as hard as a 2 meg generator.
Definitely. We've had a few more questions come in. We're a little bit over time or past our agenda time, but I think we should keep going. These are great conversations. A question for Ron: does New Orleans participate in the WARN program? And if so, has this program been successful, or have the labor shortages limited your ability to support your neighboring utilities or receive support?
I would say I'm not. Very little, somewhat. We do have CEAs, cooperative endeavor agreements between our neighboring parishes. We do have that, but as far as and I'm seeing the question right here with the labor shortages, that was quite a challenge with Hurricane Ida. It's when the storm came through, and not only you have to deal with your the work environment, but when the storm devastates the home environment and a large portion of home environment, and part of that question was labor shortages. About 3 to 4 days after the storm, it was extremely difficult to get labor to come to work for your vendors, because some of the vendors that we use on a monthly or daily basis, weekly basis, their homes and their businesses were severely impacted. So it's sort of like a ricochet effect. I mean, so Hurricane Ida was quite unique. Hurricane Katrina was our baseline. But the difference with Hurricane Ida, we didn't have the floodwaters in the metro area. They did experience storm surge outside of the level protection area, and I do feel for those parishes outside because they were really devastated. But and then I do see the second question with the gas supply, whole house generators. The natural gas worked very well during Hurricane Ida because our power plant pretty much runs off. We are dual fuel. But 100% we run off natural gas, and the natural gas was uninterrupted, which was a very good thing because we were in island mode as utility with our generators. We had all our backup our power generators cranking for a good 7 to 10 days, and the natural gas really was our survival.
Linda, do you have any concerns over adequacy of gas supply?
Well, natural gas was not an issue here, even in the extreme cold weather, the winter weather event in February that we had, where they had, peak demands more than they have ever served. And CenterPoint gas supply did great for natural gas. So not a supply concern here. I think that CenterPoint and us and many in Texas learned what anti-gel for diesel backup generators. We don't keep that stocked in our maintenance warehouse. I said something about anti-gel afterwards. I was going to go buy a case and put it on the shelf, and they were like, "Oh, we won't ever need that again." And I was like, "You're nuts." So I think that type effect. We did have people, and we do have a couple of rural locations where we run on propane, and getting an additional propane delivery during an event really woke us up to the size of tank we might need for an extended outage of supply there.
Yeah, absolutely. Joan, is there anything that you wanted to add on
Well,
that?
I think the one thing that us as utilities are going to have to keep in mind is that although natural gas was available to most of us for generation, and that it did make a huge budget difference, is the spot prices for natural gas were extremely high. So we saw that in some of our electric utility bills after the event, especially on the smaller rural electrics that didn't have long-term contracts for natural gas and had bought more fuel on the spot market. Received some very high bills that were 10 plus times what they would normally be, and along with even with like PSO and that are regulated by the Corporation Commission, is I think the residential meter rate for PSO has gone up 30% after the winter event. So a large impact to costs for the utilities and for customers, and that related to fuel costs that occurred during that event.
Yeah, I think that's actually an excellent segue. A lot of the topics that we discussed during this Q&A and during your presentations are things that we actually do include and cover during CREATE exercises and in the CREATE framework. So what I definitely want to just highlight that we'll be getting to those types of impacts and how to assess those with within the CREATE framework themselves. At this point, we are about 15 minutes behind schedule, so I do want to suggest that we go to a quick, maybe 10-minute break. Everybody, thank you so much for staying on the line with us and continuing on with today's workshop. We are going to switch gears. Now we focused a little bit on climate change and climate impacts for the first half of this workshop. And now we are going to focus on CREATE, the Climate Resilience Evaluation and Awareness Tool from US EPA, and the climate resilience assessment that can be conducted with this tool. So from that, I'm going to hand it over to my colleague Galen to continue on with our presentations. Take it away, Galen.
Great, thanks, Alyssa. So thank you to everyone for sticking around for the rest of our presentations. We really appreciate everybody joining today. So one goal of the workshop is to introduce you all to CREATE. So I'm going to do a quick overview of CREATE and how water utilities can use this tool to understand their climate risk and resilience. So CREATE stands for the Climate Resilience Evaluation and Awareness Tool. And this is an online tool that guides utilities through a risk assessment to help make decisions about actions they can take to build their resilience to climate change. And the typical users for the tool are generally drinking water and wastewater systems, as well as stormwater utilities. This tool was developed by EPA's Creating Resilient Water Utilities team as part of a suite of resources. And some of these resources I'll go over later in my presentation. But the purpose of this tool is to help utilities assess their vulnerability to a changing climate, including to some of the weather patterns that our presenters just went over. So CREATE is customizable and flexible to the utility, and the utility gets to select climate scenarios of what they anticipate the future will look like. And they can select multiple scenarios to capture the range and uncertainty about what our future will actually look like in terms of weather patterns. And the utility also gets to select the relevant historical and projected climate data for their area, as well as the economic consequences that they anticipate as a result of some of their climate threats. And the final results in the tool help the utility compare the amount of risk reduced by their adaptive measures to the cost to implement each of their adaptive measures. And this slide is an overview of the 5 modules in CREATE. I'm going to dive into each of these in my presentation, and later in the workshop, Alyssa will also dive into these when she does a live demo on how to use CREATE. But this is a good overview of each of the modules and the inputs that go into each module, as well as the outcomes that each module achieves. So the first module is climate awareness, and in this module, the utility adds their system information and their specific concerns at their utility. And in the next module, scenario development, the utility decides what threats to focus on in their analysis and develops their scenarios with either their own custom climate data that they have or using the data that's already preloaded in CREATE. So these first 2 modules are fairly standard for the utility to fill out, and they're good primers for the future modules that are system specific as well. Then the third module, consequences and assets, the utility identifies which assets to include in their analysis. So this can be some of their hard infrastructure, like their treatment plants or pumping stations, or it might be some of their resources, like their drinking water resources, their reservoirs. And then in the adaptation planning module, the utility inputs their existing adaptive measures, which are the steps they're already taking to be more resilient. And they also enter their potential adaptive measures. So these are actions the utility identifies that they could take to be more resilient. And there's also a library of these measures in Create that the utilities can choose from to help jog their memory about what they may already be doing or thinking about at their utility to be more resilient to climate change. And then in the final module, risk assessment, the utility assigns threat levels to each of their assets. And from that, Create calculates consequence costs from climate change on each of the assets. And that helps the utility compare the risk reduction benefits of the different adaptive measures to see which measures are most cost effective and provide the most benefits. So let's dive in. This is the first module, again, climate awareness. And here the utility will learn about potential climate impacts that they might face in their region. And after that, they identify what concerns are most relevant to their utility operations. And as you can see with that green plus button at the top, the utility can add custom concerns if there are concerns that aren't listed here that are relevant to their utility. And the selection process helps focus the utility's assessment, but does not impact the quantitative analyses later on. So the utility can select as many concerns that apply to them. And in the next module, scenario development, the utility will select their major threats based on how they expect climate to affect their utility. So some of these threats are actually automatically selected by Create based on the utility type and concerns that were selected in the previous module. But again, the utility can add custom threats if there's a threat to their utility that's not listed here. And in this module, it's important to choose just one or two threats for the assessment to help limit the scope and focus the analysis. So next in this module, the utility will identify which scenarios they'd like to run in their analysis. They identify a relevant weather station from which to pull historical and projected climate data from. And the utility can adjust the data and values as they see fit, or they can even just use their own data altogether. And they get to select which of the three scenarios to include for their projected future scenarios. So in the blue, there's the warmer and wetter. In the middle, there's the moderate. And in the bottom red, there's the hotter and drier future. And the utility might select more than one future scenario to account for the uncertainty in what the future will actually look like in their region. And this is where the utility selects the data to include in their analysis to define their projected scenarios. So in this example, the utility wanted to look at temperature and precipitation levels that were warmer and wetter in the future. And then the utility selected, in this example, a stormy future for their intense precipitation scenario. So this means that the utility expects more intense precipitation during storms. And in this example, the utility chose higher future flows for their surface water data. So this means the utility expects a higher stream flow relative to what they've seen in the past. And coastal utilities can include sea level rise projections in their analysis. So in this example, the utility chose a high rate of sea level rise. And these sea level rise projections are based on projections of warming under a range of future emissions and ice melt scenarios. So in the third module, consequences and assets, the module comes preloaded with 4 economic consequence categories. And these categories are listed on the screen to the left, beginning with utility business impacts. And CREATE also preloads values, as you can see along the bottom here, for each consequence level from low, medium, high to very high. And these values are determined based on the utility size that was selected in Module 1. And as are most things in CREATE, these values are customizable. So if the utility has more precise data of their own, they can change these values to more accurately reflect the operating status of their utility. And the utility can also select custom consequence categories. So if something outside of these categories is particularly relevant to them, they can add those here. And then in the fourth module, adaptation planning, the utility identifies their existing adaptive measures, which are the measures the utility has already taken to protect their assets. And the utility also will identify their potential adaptive measures that they could implement to be more resilient. And these measures can be added as custom measures or chosen from the drop-down library of measures that are preloaded in CREATE. And each adaptive measure is assigned a total cost estimate, which will be used in the next module, risk assessment, to compare the value of each adaptation plan against its total cost. And in this module, the utility will also combine adaptive measures into adaptation plans. And this will combine all the costs and all the benefits of all the measures in each plan. It'll bundle them together. So in the risk assessment module, this is where the utility starts seeing their results. So this module evaluates the adaptation plans that were organized in the previous module by comparing the cost of each adaptation plan to its total monetized risk reduction potential. And this helps show whether the results suggest that the plan would likely cost less than the amount of risk that it could reduce. So that means the plan would result in economic benefit to the utility. So a graph like this one on the screen is produced for each plan under each climate scenario that the utility selected for their analysis. And in this example on the screen, the total monetized risk reduction potential that you see in green is greater than the total cost of the plan in gray down at the bottom right. So that means these results suggest that this adaptation plan would result in economic benefit if implemented. So another benefit of CREATE is that each of the 5 modules we just went over provides a report that summarizes information selected during the module. And these reports are generated in Word documents, which can be edited and adjusted to meet the communication needs of the utility. So if they're presenting this to maybe their water system board or a town hall meeting, they can edit these Word documents to be able to present to whatever audience they're targeting these to. So that was an overview of the 5 modules in CREATE. But as I mentioned, in addition to CREATE, EPA's Creating Resilient Water Utilities team has a whole suite of other resources for how to identify climate vulnerabilities and enhance resilience for utilities. So one example is this climate scenarios projection map. And this is an interactive web page that allows either current users of CREATE or the general public to discover what types of climate projections are included in the tool. So these are screenshots of some of the climate projections within CREATE for precipitation in your region under a warmer and wetter and stormier scenario. So you can toggle between the different maps to see what the region looks like in your area. And CREATE has been used by drinking water and wastewater utilities all over the country, and case studies have been developed for some of these utilities. And this helps provide examples of ways to use CREATE so that others can learn from them and see how they could potentially use CREATE at their utility as well. So I'm going to highlight one case study that is available now, and then we'll get to hear from Lafayette Utility System about how they use CREATE, but their case study will be posted in the coming weeks. So this is the case studies user interface. As you can see along the left, you can filter case studies by threat category. So these categories align, you may have noticed, with those that are included in CREATE itself. And as you can see, flooding is selected here, and flooding has been assessed by CREATE at utilities all across the country, including in Atlanta, Georgia. So this case study is from Atlanta, and to provide capacity relief to their sewer system and help reduce sewer overflows, the city had built their South Fork pump station and equalization tank. And this was built to help collect incoming water when the upstream flow increased during wet weather events. But even with the pump station they already had, there continued to be sanitary sewer overflows, which degraded the water quality in their area. So with their CREATE analysis, Atlanta identified how their current adaptive measures were already effective against climate change. And they also identified additional projects, which are their potential adaptive measures, which were projects that they could implement to further enhance their resilience of their pump station to reduce sanitary sewer overflows and protect their water quality. So there are a lot more case studies from communities across the country, and you can find these by Googling US EPA CREATE case studies. Or if you are using CREATE, you can follow this case study and information exchange map link, which is located in CREATE's resource library. So that concludes my presentation. I can pause for any questions and then pass it back to Alyssa.
Thanks, Kaylin. I don't see any questions that have come through the chat so far, but if you do have questions, please feel free to submit those, and maybe I can address them during our demo or at the beginning of the demo, or Kaylin can come back on and address them before the demo. So thank you, Kaylin, that was great. And I would like to now invite Trevor to turn on your camera and to take control of the screen so that you can begin sharing your presentation about the CREATE exercise that we did with you earlier this year.
Let's see. All right. Thank you, ma'am. Good afternoon, everyone. Let's see. Am I on the screen now? Yep. Looks it. Okay, well, hello. My name is Trevor Carrier. I'm a civil engineer here for Lafayette Utility Systems, dealing with the water, wastewater infrastructure here in town. Also with me is Mr. Craig Gotro, our water, wastewater operations manager, and along with Keenan Menard, who is our drinking water plant supervisor, operations supervisor here. Do you guys want to chime in and say hello?
Hello, this is Keenan.
Keenan
Hello.
and Mr. Craig Gotro. There you go. So, if you hear them chime in or add their 2 cents to my presentation here at any point, um, anyway, guys, feel free to jump in whenever needed. So anyway, moving on, we'll talk about our experience with the crate exercise. And just a quick overview of what I'll be going over today. So we did a case study here. We'll look at our goals, at the assessment we did, the outcomes from that assessment, and then our key takeaways from the product as a whole. So the goals with this CREATE exercise was to assess the potential impacts of floods on the LUS assets that we looked at, as well as to evaluate the resilience of potential adaptive measures, including the installation of a retention basin, increased plant storage, as well as raising some components above future flood levels. Another goal we had was to utilize the CREATE tool to output products to explain the importance of the planned or potential resiliency measures. So some of our current concerns when we first started this assessment was, of course, the natural disasters, in particular hurricanes and high rainfall events, as well as sea level rise, peak service challenges, as well as our service needs. And just to give everyone a little insight, we are a utility that produces about 20 million gallons a day of water, and we serve about 127,000 people. The threat identification we chose to look at in the assessment was, of course, the flooding. Rob touched on a few different storms we've had in the past few years, and we definitely have felt the effects of that in regards to our drinking water plants and other assets we have, as well as we have to start looking at storm surge coming into our area through the Vermilion River that comes up from the Gulf of Mexico. As Galen mentioned, in the CREATE assessment, you can look at multiple different future considerations. And we decided to look at 2 different scenarios, one being the moderate future, where we'd have slightly warmer summer temperatures, very little increased precipitation, but an increase in the 30-year intense storms, as well as we looked at a high precipitation future with more storms, with again an increase in summer temperatures, an overall increase in precipitation, and a even higher increase in the 30-year intense precipitation events. The assets we chose to pair in the CREATE assessment was one of our bigger plants here. We call it the Southwater Treatment Plant. It was built in the 1980s. We typically produce about 11 million gallons per day at this site. It's a traditional lime softening plant using gas chlorination. This site in particular really felt the effects of the 2016 flood event we had here in town, as well as a lot of the southern part of Louisiana. Since then, we've installed some storm doors on our filter galleries where most of our electrical actuators and other equipment is in. During that storm, we had about 10 feet of water flood that room, and really wiped all of that equipment out. We had to, of course, bear the cost of changing all that out. We also added some concrete walls around in some particular areas, as well as raised the vents on our wells here around that facility. Another asset we looked at was our Commission Boulevard drinking water plant, which is really a small booster station that we use here. It's a hypochlorite and phosphate plant where we just inject that into the system. Currently have a big upgrade at that facility where we're going to be doing a more traditional style treatment plant. And in regards to that construction, we're going to be building a 1 million gallon storage tank on site as well. Galen touched on this as well. The CREATE exercise gives us a look at some economic consequences. And as you can see in the chart here, if we look at a low level, we'll have little to no impact on the utility equipment damages as well as environmental impacts. But in hindsight, if we see the high end of this, we'll see significant damage to our equipment as well as large environmental impacts that can be corresponded into dollars, and always looking to keep those as low as possible. Some of the adaptive measures we inputted into this CREATE assessment was surrounding the South Water Treatment Plant with a retention pond, which we've thrown around that idea in the past and continuing to look at that, as well as increasing the drinking water plant storage at the Commission Boulevard site, as well as increasing the drinking water plant storage at the South plant. And again, raising our mechanical components, not only at the wells, but at the drinking plant in general, above projected flood levels. So in the CREATE tool, you pair the asset to a threat. And in this bar graph or chart, we're looking at the Commission Boulevard drinking water plant under the floods threat that we implemented. And you can see that under our current measures, which are other things we plugged into the tool, in a high precipitation and stormy future, we're going to have an increased threat to our system here. Whereas if we implement the adaptations we came up and plugged into the CREATE tool, we're going to see some lower threats in the high precipitation and stormy futures. And the following slide here similarly looks at the same thing, but it's at the South plant. And again, when you look at our current measures, if we do in fact get that high precipitation and more frequent stormy future, our threat assessment is going to go up real high. Whereas if we look at the middle rows right here, if we do implement our full adaptation plan, we can potentially keep those threats to a minimum. We also looked at it again at the South plant plan, but we removed that retention pond. And you can see we had a nice medium between the two. And it was interesting to see that pond really did make a difference. And so we're continuing to look and plan to implement that here in the future. So the outcomes of the CREATE exercise: the total monetized risk reduction benefits could exceed the total cost of the South plant adaptation plan, even under a moderate future scenario, giving us a positive result. So we can see here that the money spent in the adaptation plan will offset and actually save us money here in the long run, should we choose to implement that plan. Again, we look at it where if we look at the higher participation future, again, a positive outcome where the money we we potentially will spend on this adaptation plan will save us money in the long run, as well as other things. Some of the takeaways from the CREATE exercise that we did was we were able to get some good reports and visuals that we can use to gain support from our municipal stakeholders, as well as city councilmen, to implement these projects as well as other CIP projects that we really need to proceed with to prepare for the future, as well as to explain the importance of these adaptive measures in the increasing system resilience, which I think everyone can agree is a hot topic, and we all should be trying to proceed and get a high level of resilience in our drinking water systems. In the future, we can consider climate threat from freezes. We can assess other assets such as the North Water Plant, which is another facility we have. And these are all things we can use this CREATE assessment for in the future. I kind of misspoke there, but yeah, so we can use the CREATE to look at our other drinking water plant and see what kind of ideas and scenarios we can get out for that plant, as well as we can toggle between economic consequence levels, changes the risk and reduction benefits, as well as evaluate the expected frequency of storms and impact on water level to help prepare for the future. CREATE can be a guide for presenting potential consequences, relative benefits, and likelihood sensitivities for a suite of prospective adaptive measures. The CREATE exercise, we were able to consider climate scenarios on a cost-benefit analysis. We were able to utilize a sensitive analysis to investigate different climate scenarios and quantify their impacts, as well as provide strong case studies for water systems in this region to grow their resilience planning. And I thank everyone. It'll kind of wrap me up. It was kind of quick and brief, but I tried to touch on as much as I could. So if there's any questions, I'll try to answer as best as I can, maybe with help from others. So.
Absolutely. Thanks, Trevor. That was an excellent presentation about the overall, CREATE exercise with you all. I think it was a lot to get through in just 20 minutes. So I think I don't see any questions. If folks have questions, please feel free to put those in the chat. Keenan or Craig, do you all have anything that you'd like to add about the exercise itself and some of those takeaways and things that you learned?
But we learned a lot about, just the different scenarios. We never thought about, we should never have built a basement in a water plant in South Louisiana. So doing all these adaptive measures that is going to help us save a lot of money and keep our plants from flooding in the future. And they really helped with this particular exercise to see those things. And I want to thank y'all for helping us work through all this stuff.
Absolutely. We're happy to do it. Keenan, anything from you?
I think it was interesting to see some of the stuff we were already planning, that the exercise showed that we were on the right track, which was good to know, and also just pointing out some other stuff that we hadn't considered.
Absolutely. All right. Well, I don't see any questions coming in at this point, but I hope that you three will be willing to take questions maybe at the end if any come through specifically about your exercise. And I think I will go ahead and start sharing my screen so that we can jump into today's demo of the CREATE program. So I will take control here. All right. Can everybody see my screen?
Yes, looks good.
Thank you, Galen. Awesome. So this is EPA's website. If you haven't been on it before, this is the webpage for the CREATE program to access Create. So you just click this login here, and the U.S. government doesn't typically update their large-scale data systems, but in fact they did last week. So there's a new way to get in through login.gov. So bear with me while I log in here. But while this is thinking, let me just highlight a few things that we have on this website as well. So Crew not only has the Create tool to be able to for water utilities to use, but there's also the Resilient Strategies Guide, which is similar to Create in scope, but a little bit different in intensity. And so for those of you who are interested in just dipping your toe in, I would definitely recommend this tool as a first step. There's also the Create methodology here. So if you're interested in kind of the back end of the framework, this is a good place to go. And then also the scenarios map that Galen pointed out in her presentation is right here. So you can take a look at that as well. So what I'm going to do here is give a quick overview of the framework itself, and then we are going to jump into a demo file that I've created to show you kind of the intricacies of the tool and specifically how to customize it for information that your utility is particularly interested in. So let me just go ahead and close that. So this is the homepage of Create, and there are YouTube videos here, and unfortunately the links are broken, but they are actually up here in the help section if you would like to take a look at those. So there's a welcome video and then videos for the different modules as well. And also the methodology guide is here. So if you have, if you're in the tool and have a question, you can always find that right there. So the way that you work, oh, and then also I'll just mention the resources tab that Galen also pointed out earlier. It takes a second to load sometimes, but here we are. So these are the different resources that are embedded within Create. And so you can take a look at these. This is more just educational, and that case study information exchange map right here. So these are just good resources for you to take a look at if you're interested in beginning your planning and want to do a little bit of homework before you jump straight in. So the way that you get into the tool is either this Get Started button or this Get Started tab right at the top. And this will bring you to your library. As you can see, I do this for a living, so I have a lot of assessments in here. But yours will likely be empty when you make your login. And you have 3 different options of what you can do to make an assessment. So you can build a new assessment, which is what most folks will start with. You can import an existing assessment, which is an export of a Create file that you can then upload and work on. So say if you're working in a team, you would be able to share files that way. Or you can rebuild an existing assessment. And that's actually what I'm going to do today, because I've completed this workshop demo here, which I will just show you that I've completed this assessment. So all of these green check marks indicate that we are done. And these are, if you remember Galen's presentation, these are the 5 modules: climate awareness, scenario development, consequences and assets, adaptation planning, and risk assessment. So I'm going to go ahead and rebuild this assessment so that I can show you some of the customization options that are available here. No, save assessments. Here we are. Okay, so I'm going to go ahead and click rebuild, and this is what pops up. So I'm going to select this demo file here, and I'm going to say, instead of this name, oops, popped out there. Instead of the name that I currently have, I'm going to call it Benton, oops, excuse me. Bentonville Water District. As you'll see, that's the demo utility that I've chosen here. So we're going to just click rebuild, and it will think and create a brand new file here. So I'll click resume, and you'll see that we are at 0% complete, which can scare someone at first, but don't be alarmed because all of the information is saved. It's just restarting at the beginning to start over and maybe make some changes. So while this loads, I will go ahead. Yep. So here is the very first. So we're going to start with the climate awareness module. And this module is very simple. Essentially, it just takes some information about the utility, the location, the ownership, population served, with system type, and general MGD. This is just essentially getting a framework of what your utility is, how your utility functions. So once this is all filled out, essentially, so this water district is in Bentonville, Arkansas. I've chosen a city that I found online, so maybe some of you are aware of this area. So I'm saying that the population served here is 52,000, and that they produce about 34 million gallons per day. They probably have a big industry around. The next step is learning a little bit more about climate change. And since you all have attended this workshop, I would say that you're probably a little bit more up to speed than some of your colleagues. So pats on the back to you. But this is a good opportunity for you to understand some of the impacts that could be that you could realize with your drinking water or wastewater utilities. So these are climate challenges by theme, so drought, water quality degradation, flooding, and these dots over here indicate how impactful they will be to the utility, either a drinking water utility or a wastewater utility. So for example, this is the science is looking like reduced groundwater recharge is going to be more impactful for a drinking water utility, for example, than a wastewater utility, which makes some common sense. And then reduced groundwater recharge in the Southwest is going to be more impactful than changes in seasonal runoff and loss of snowpack, which also makes a little bit of logical sense. And there's also some additional resources here. If you want to dig further into some of this climate information, you can click this more information button and it will take you to some additional resources. So again, this step is mostly about education and learning about what could come, but it's a good step. It's a good next step and a kind of a baseline step of working through the rest of the scenarios and modules. So this utility that I've created a demo for is concerned about natural disasters like large storms, as well as making sure that they can meet peak service requirements. And they're also concerned about water quality management and that they've been seeing some degraded water quality during some of these natural disasters and big storms. So those are the three concerns that they decided on. They obviously, Arkansas is not a coastal community, so they did not choose sea level rise. And the rest of these, the utility didn't feel that they were fully applicable to them. And then the last step is this awareness summary. So at the end of each of these modules, you'll see that there is a downloadable report of the information that was added to the framework. So these come out of the tool in customizable and editable Word documents. So again, you see this is Bentonville Water District, and it just provides some information on climate change as well as how it could impact the utility in general. All right, so that is the very first module. It's very, again, the first one is trying to ease you into the rest of it. So it's a simple module. It's very just getting the basics together and finding that, getting all of kind of that foundational information together. The next module is the scenario development module. And again, these videos are up right here. So the scenario development module, you can click that. It will take you to YouTube and you'll be able to watch this video. So the very first step is identifying that threat. What is the threat that the utility is particularly concerned about? And for this demo, and to try to be cohesive with Lafayette's exercise, I chose the threat of flooding. So we're going to take a look at flooding and how flooding impacts are going to be realized in Bentonville. So once you've decided on your threat, then we start to think about the climate scenarios and really what type of climate information is relevant to this community. So what's nice about Create is that there are these customizable approaches. And so you can turn on and off these different categories of data. So automatically, when you start a Create exercise, you have temperature and precipitation. And then you can turn on these other categories as well. So we'll just take a look at temperature. So this utility decided to include temperature, precipitation, and surface water, and then also decided to add a custom value. But I'll start with selecting temperature locations first, and then we'll go to the customized data. So Create has climate data built into it, as you can see. So what this step does is that you're pulling, you're identifying a temperature station that you want to pull historical data from. So based on the address that was added in the climate awareness module, it's identified the utility in this weather grid. And so if that's correct, then you can select next. If it's not correct, you can select a different grid. But I'm going to select this one, which is the correct grid. And then this is going to show us all of the weather stations that are available in that area. So you can see there's quite a few to choose from. So I could choose a different one if I wanted, or I could select the one that is closest to the utility address that, that I added in the climate awareness module. So I'm just going to save this one. And then you can choose your measurements here. So there are different, there's a customizable amount of categories of data. So for example, you can take a look at annual temperature if you want to be less granular. If you'd like to look at monthly temperature, you can absolutely do that. I've selected the 3 kind of spring months here, or late winter, early spring. And then I've also selected hot day data. So there is a number of days above 90, number of days above 95, and number of days above 100. And again, remember, these are historical data sets. So this is where we're shaping our climate scenarios for the type of data that we'd like to include. And then looking forward, we will look at the projected scenarios and the forward-facing climate data in the next step. So what I am going to do here, though, is I'm going to include a custom category so that we all can take a look at how this works. So one of the things that this utility has identified is that they're concerned about flooding and high storm events and the potential for a dam, the dam that holds back their reservoir, to overtop and overflow, and the impact that that would have on them. So I'm going to add here dam overflow days, maybe just dam overflows. And then I can put in here, the unit is number of days. And then I'll click save. So you'll see in the next screen so if we're happy with our categories here, we'll see in the next screen that you're able to take a look at the data that's included in Create. And so if you disagree with something, or you think that it's not quite accurate for you, there is an opportunity to customize that information. So then this is now editable. So if you say instead the average temperature is 90 degrees, which would be quite horrifying for Arkansas, but I believe it said 57.73 is the Create value. So that's just the way that you can customize this data. And you can do that for all of these values here. And so I've added this custom data set, and historically the utility has said that the dam has overtopped on average 1 day a year. And the concern there is that that amount of water is actually pretty damaging to the structure of the dam overall. So once I'm happy with this information, I can go ahead and click continue, and we can move on to the next step, which is identifying the time period that this assessment should include. The important thing to consider for identifying the time period is that that CREATE has 2 different climate data sets. One is a 2035 projection and one is a 2060 projection. And again, we're getting to the point that 2035 is not very far away, and that 2060 is actually not very far away either in terms of planning for these large-scale assets. But choosing the time frame is going to identify, or is going to help the tool pull data from either the 2035 or the 2060 projection. So if we chose 2050 like we did here, we're pulling from the 2060 projection. So just keep that in mind when you're thinking about a time period. The other thing that I would highlight for the time period is if there is, regional planning or additional planning going on within the utility, it might be a good idea to pair your time period with whatever other planning measures that are happening, so that the 2 different studies and assessments can be cohesive. So once we're happy with the time period, we can go ahead and move on to the projected scenarios. So this is where we start to look to the future, right? So we have our baseline scenario, which we can take a look at, and then we choose a new scenario. So we click this button, Add Scenario, and this is where Galen highlighted the additional information here. So you can choose your conditions and what types of climate data you'd like to pull in here. Again, you have the warmer and wetter, the more moderate future, or the hotter and drier future. So you can toggle between those and take a look at what it looks like. You can change your precipitation scenarios between historical, very stormy, and kind of in between the two, and not as stormy future. Surface water scenarios, so a historical, lower, or a higher future scenario. And then again, our custom measurements. So this is where we'd add our projections. So if we wanted to say, actually, I'm going to have to change this in the current scenario that I've developed. So I already developed a higher precipitation future scenario, so we can edit this in this screen. So for this, I've chosen the warmer and wetter. So again, I think thinking back to our presentations, this is going to be this type of scenario is going to be less relevant to someone who's looking at the extreme heat like Linda was discussing, and maybe more appropriate for a future that's really looking and focusing on being wet. If you wanted to do both hot and wet, you could do that, but you'd want to adjust these temperature values here to be more in the line of what this hotter and drier future condition could look like. So it would take some customization, but it's definitely doable. So what I'm going to do here, so actually let me walk through all of these. So we've chosen our warmer and wetter future condition. I've identified a future that's stormier, so we're getting more intense storms and higher amounts of precipitation from these storms. You can see 2.3% or 23%, excuse me, and 26% increases in 50 and 100-year storms is what this is looking like. Surface water scenarios, so we've chosen a higher future flow. And then for these custom measurements, I'm going to put in here 10 days of overflows instead of just 1. So once we're happy with and you can add as many scenarios as you like. I would just mention that with each climate scenario, it makes the asset threat pairing at the end fairly unwieldy. So you want to get, you want to identify what your future climate is, what future climate you're interested in, and then just stick to that. And then if you'd like to, make adjustments in the future, you absolutely can do that through that rebuild function that I'm currently showing you how to do. So once you're pleased with the projected scenario, we can move on to the threat definition. And what we do here is, we can let it think for a second. Essentially, this is an opportunity for us to qualitatively capture some of the climate threats that could be impactful to the utility. So you can see there's a drop down here. So for flooding, the two different categories of flooding impacts are coastal storm surges or high flow events. Obviously, since we're looking at a utility in Arkansas, coastal storm surge is very unlikely. But so we've chosen these high flooding events for both the future or the baseline and the future scenario. And so this is where you would, look at, add some additional information here. For example, the concern with this utility is that high precipitation events may impact the structural integrity of the dam on the Rock River. So then we can save that as a way to capture that concern. That's not really there's not really a way to add that concern in any of the other parts. So that's where you would do that. So you click continue, and then you've completed the scenario development module. So the next module is the consequences and assets module, excuse me. Again, this video is available in the help section. So this is where we get into some of the quantitative questions and the quantitative data that is utility specific. So this consequences matrix is again focused on economic risk and economic impacts to the utility. There are 4 consequence categories included in CREATE itself. There's utility business impacts, utility equipment damage, environmental impacts, and source and receiving water impacts. So in this example, we are going to keep all of these categories, but if you were going through this assessment and identified that, utility business impacts just really isn't something we want to consider, we can turn that off through this toggle button right here. Additionally, you can add a custom consequence, which pops up this drop-down menu, and you can fill in information based on the category that you'd like to see added here. So once we've looked at all of these values, and again, these are customizable. So if this was, too low, or if you wanted to increase this value, you can do that here. I'm gonna not change that value, but you can also change the description of these if there's something specifically that you want to address in a low, medium, high, and very high category or level. So just featuring here how customizable and moldable the framework is to make it as optimal for you as possible. So again, once we reviewed that consequences data, some other kind of scoping decisions about what's going to be included in your assessment. CREATE has the opportunity to include regional economic consequences, which actually the Lafayette system did include in their assessment. So they took a look at the regional economic consequences of an outage or of, their system being impacted by by climate. And so that was able to be captured in this through using the Water Health and Economic Analysis tool, or WEAT. And so you can toggle this on and off if you'd like. For the sanity of this demo, I'm not going to consider this, but that is definitely available to you. Additionally, you can take a look at public health consequences. As I think Rob portrayed fairly well, there are some intense public health considerations when we're looking at climate change and these climate change impacts, especially with utilities. And so you can turn this on if you'd like. And so this would include value of statistical life and value of statistical injury. And again, for kind of the keeping this demo as streamlined as possible, we're not going to consider that in this assessment. So we just toggle that off. We are. So the final step in the consequences and assets module is the asset definition step. So this is where the utility would identify which assets they think are vulnerable to climate change and how they can and they want to try to address what they can do about it. So this utility, the Bentonville Water District, identified the dam on the Rock River, so Rock River Dam, and there's a description here that you can edit. Again, very customizable. You can change whether it's relevant to different categories. And what I'd like to highlight in this step is that there is an asset library here. So if you're not sure where to start, you can take a look at some of these options. For example, a drinking water treatment plant. You can take a look at your groundwater sources, so your injection wells or your aquifers, your power supply. All of these are already built in, but if there's something that's custom, again, there's that custom asset right here that you can include. So for this demo, we're just going to be focusing on this dam. And again, that's the end of the consequences and assets module. So here is your summary report that is downloadable and customizable. So the fourth module here is adaptation planning. And we will just jump right in. So this is where we get into the question of what can we do about climate change and climate impacts that are projected to come to this utility and impact this utility. And we take a look at adaptive measures in both the existing capacity, so what the utility is currently doing, as well as the potential capacity. So what could we do that's either different or building upon what we're already doing? So this utility identified that really the only thing that they're doing at this moment in time is an annual inspection. So it's a dam and flood control inspection. So it's a yearly review of the dam and sluiceway and to identify if maintenance is required, and it includes an engineering report every 2 years. So the total cost identified for that is between $15,000 and $20,000. The utility provided that information. And I do want to just point out as well that there is an adaptive measures library that Galen also mentioned during her presentation. So here you can see there's a lot of different options here. Construct, you can construct a levee, construct a low head dam. And so this is just a good place for a utility to start. You can do modeling. A good place for a utility to start if you have questions about what you could do, or maybe you want to think through what you are doing and see if any of these categories are things that you're currently doing. So this utility again identified that the only existing measure that they have completed is this biannual inspection of their dam and flood control. So then the next step is identifying potential adaptive measures, and the utility identified 2 potential measures that they could do to help protect their dam. And the first is reinforcing the dam structure, so making it stronger and more resilient. And again, we can take a look at that here in the description. So preventing dam failure, reinforcing the dam may be required. Without this dam, current source water sources may not exist. And to reinforce the dam, they estimated that it would cost between $115,000 and $175,000. You also could change that and add a single value if you have it. If not, this range is completely acceptable. The other option for the utility was to identify alternate water sources. So potentially abandoning this dam if it were to become, you know, structurally unsound or unable to provide that resource, essentially. So the description here is developing redundant capabilities for water supply, including water storage, water sources, treatment plants. And this was one of the adaptation library, or a measure from the library. So this is a description that's already built in. And the total cost estimated was about $250,000. Okay, so now that the utility has identified their potential adaptive measures, we have to bundle these measures into plans. So essentially, they could have combined the two potential adaptive measures to say that they were going to implement both of these, or as is the case here, they decided to keep these different measures apart because they wanted to compare the two. So you can see here that the identify alternate water source is one of the plans, and then protect current water source is the other plan. And then the final plan here is the current measures plan, which is built in to the tool. And the benefit of doing this is that Create can give you the cost effectiveness of implementing these plans, but it also gives you the cost of doing nothing. So it identifies for you what the impact would be to the utility if no action was taken and this climate that we outlined in the scenario development module was realized. So I think that's a really important value in the Create framework, because you're allowed to see kind of the cost of inaction, which a lot of folks don't necessarily consider. And that is the last step of the adaptation summary. Risk assessment. Okay, so this is where all of the pieces come together, and where we think through really how the scenario that we developed in Module 2 would impact financially the assets that were identified in Module 3, and whether the adaptations outlined in Module 4 will reduce the economic consequences and reduce the risk to the assets. So you do that through this asset threat pairing step, which Trevor did talk about during his presentation. And so this is essentially what it looks like. So again, if you want to review your consequences matrix, you can take a look at it right here. These are the economic categories that we included that the utility identified were acceptable. And so for each of these adaptation plans, we're starting with current measures. We're taking a look at what the impact would be to the asset, which is the Rock River Dam, under the threat of floods. So if we take a look at this, under the baseline scenario here, the utility identified that the utility business impacts from flooding is low. So you can see this drop down here. So we've decided that it's low. And then under the higher precipitation future, the utility business impacts would be closer to medium. So we're seeing an increase in the impact. Again, we'll look at this through each of these consequence categories. So utility equipment damage. The utility is saying that in the baseline scenario, they're seeing about a medium level of damage from flooding. But under a higher precipitation future, they're seeing a high level of impact. And then again, under environmental impacts, they've identified low and medium, and source and receiving water impacts both medium under the baseline scenario and a high precipitation future. And so again, this is if we do nothing. If we have our current measures and we continue those in the future, what would the impact be? And then next, we take a look at protecting current water sources. So this is the reinforcing of the dam structure. So if we reinforce the dam and we see these two climate futures, what would the impacts be on the Rock River Dam? And so you can see here that CREATE has cut off, you don't have all of the options available to you anymore because CREATE assumes that by implementing an adaptation plan, it's going to reduce the risk. It's not going to increase the risk, so you can't have these higher categories. But essentially what the utility identified was that for utility business impacts, there isn't really going to be a change. They're still going to see the same amount of operations and maintenance, and they'll see similar costs to their utility, low and medium. But under equipment damage, they're saying their risk goes from being a medium to a low, and that under a high precipitation future, their risk is no longer high, but it's medium. And then for environmental impacts, we're seeing low, and source and receiving water impacts are the same at medium and medium. And then finally, the last adaptation plan is identifying alternate water sources. And so by doing that, what the utility is saying is that they wouldn't need to operate their dam as much, so their utility business impacts would go to being low. Their utility equipment damage would also be low because they would no longer have to maintain, or the dam being, impacted by flooding would be less impactful to them, and they could even get rid of it, is what they're saying. So then everything is pretty much reduced risk here, all the way to low. So that's the asset threat pairing step. So it's, again, very detailed, very slow, methodical, but ultimately, once you walk through that step, you get your risk results. And this is the graph that Galen was showing and Trevor showed during their presentations. So I'm just going to zoom out a little bit here so that everybody can see everything at the same time. So the way that this graph works is that this red bar is current consequences. So what the current measures, so what the utility is doing today, what those consequences are in terms of climate impacts. And so the utility is seeing between $10 and $27 million of consequences during a flood, just based on what they are currently doing. By implementing the adaptation plan, which is currently selected as protecting the current water source, so reinforcing that dam structure, we see this bar reduce to about between 5 and 17 million. So still quite a lot of consequences, but much lower than what we're seeing here. And then the monetized risk reduction is the difference between these two. So we're seeing between $0 and $14 million of benefit, right? Which is a very large range. But if we take a look at that range compared to the adaptation plan total cost, it's very likely that we would receive risk reduction based on the adaptation plan total cost. And this is under all scenarios, but you can look at it under the different climate scenarios. So baseline scenario, it looks like this, whereas the high precipitation future, we see more risk reduction. And then we can also take a look at the other adaptation plans, so identifying alternate water. So under a higher precipitation future, we're seeing quite a lot of risk reduction here by identifying alternate water sources. So essentially, the best case scenario when you're seeing the risk results is one like this, where the total monetized risk reduction, this green bar, does not overlap with the adaptation plan total cost. So this is essentially what the tool is saying, is that the risk reduction is almost guaranteed to be greater than adaptation plan total cost based on the information that you've put in this tool. So another way to take a look, so those are the risk results in graphical form. And then another way to take a look at some of these results is likelihood sensitivity, which Trevor showed one of these graphs as well. So what this looks like what essentially this means is it helps utilities understand when they would want to consider implementing or not implementing these plans based on the information found in the risk results. So with the adaptation plan of protecting the current water source and the baseline scenario, so if essentially what this tool is saying is that if we are 2.3% confident that the baseline scenario will occur, then we should get more information about the current adaptation plan, and that maybe there's additional benefit that could be found, or maybe there is maybe we can find a better cost range. We can identify how much it would actually cost instead of kind of the range that we were taking a look at in this assessment. And then if we, well, actually, let's change it. And then for the high precipitation future, this again is looking fairly similar. So we're consider implementing the plan is really dominant here. So the tool is indicating that you probably want to gain more information before implementing this plan. And then I gave you a little preview. So for the identifying alternate water sources, under the baseline scenario, we see something similar. But under the high precipitation future, we start to see this green, right? Where this is saying you should probably implement this plan just based on the information added to the tool. So what this is saying is that if you are 8.36% confident that the higher precipitation future will occur, that you will see economic risk reduction based on the information put in this tool. So it makes good business sense for you to implement that plan in this situation. So that's the likelihood sensitivity. And then the very last step is plan comparison. And so what this does is it helps, again, kind of capture some of these more qualitative as opposed to quantitative results of these plans, and some of those impacts that are more specifically going to come from these adaptation plans. So the qualitative categories are energy impacts, socioeconomic impacts, and community public health impacts. And so you can take a look at these drop-down menus of what level of impact each adaptation plan would have, and compare them to each other. And that is the last step in a create analysis. So at the end of that, you can complete the analysis file, and then you have 100% complete, an assessment that is 100% complete. So that is a very quick demo of the CREATE framework. And I'd like to to open the opportunity for questions. It seems like maybe we did get a question in there. Galen, did we have any questions come through?
No questions right now.
Okay. So what I will do then is I will stop presenting, and I will have and we will just have take a quick moment to see if other questions come through. And if not, then we may actually be able to end a little bit early. I realize it's after 5 o'clock on East Coast time, which some of us are calling in from. But yeah, any questions that you have, please feel free to send those our way. And I hope this was illuminating to you all, and that you learned something about the CREATE framework, and hopefully a way to implement that for your utility. Any questions? Well, I appreciate you all so much for joining us today. It looks like we don't have any questions, so that is totally fine. So thank you so much. And Steve, I don't know if you would like to give a quick send off, but
there is a question.
Oh, there is a question.
Yeah.
So the question was, how does the CREATE framework complement AWEA requirements? That's a great question. And we did touch on AWEA requirements earlier in this session. But AWEA actually does not require utilities to consider climate change. So what EPA has done to make the CREATE framework and AWEA risk and resilience assessments compatible is that the VSAT tool, which many small water systems use to complete their risk and resilience assessments, they are actually they integrate essentially. So a VSAT file, which comes out of the VSAT tool, can be uploaded to CREATE to help make the process a little bit more smooth. But essentially, yeah, so like I said, AWEA doesn't require climate change to be considered. It's more current threats and hazards. So the risk and resilience assessments are a great starting point for these CREATE exercises and assessments because you've already identified some threats. You've kind of practiced this skill set of identifying risks and what you can do about it. So I would say it does complement the AWEA requirements, but it doesn't. They're not exactly in line, if that helps. Any other questions? Good question. Awesome. Steve is saying that his mute button is not working, but he thanks everybody for attending. And Steve, maybe you could put the crew email into the chat box in case folks have questions. They would like to go directly to the to you all. And I would also say that if you all are interested in technical assistance to conduct a CREATE exercise, or if you think that if you have maybe folks around you that you think would benefit from a CREATE exercise and some technical assistance, that is available. And so you just need to reach out to the emails that Steve just put in the chat box right there, and we can try to identify a time frame and opportunities for that technical assistance. So again, I really appreciate everyone tuning in today. I think it was a really good turnout. I was very pleased with the amount of folks that we saw on the line. And please do reach out if you all have questions or additional considerations that you'd like to talk through. We are here and we are available whenever you need us. So with that, I will go ahead and say thank you and have a great rest of your day.